Hello, guys. Good day, everyone. This is Prime Concept. You're welcome once again to my channel. I'm sorry actually for starting a bit late from our scheduled time. So, you are all welcome to this channel, and we want to use this period to have a very intensive revision class. Most of you, especially those from UNN, you'll be writing your calculus, that is Maths 102. And for some other schools like Unizik, ESUT, SUMAS, they call it Maths 103. Now, but for those in UNN, you'll be writing this exam tomorrow. So it's very important that everybody that is offering Maths 103 is found present on this live session. All right. So we won't waste much time. We would want to dive into the business for today because we have a lot to handle, right? So for UNN students, they call it Maths 103. Other schools, Unizik and so on, SUMAS, ESUT, they call it Maths 102. That is for their second semester. So if you are joining from anywhere, feel free to follow up because the topics are the same for every school. Now, if you are present already, I want you to hit the like button, register your presence so that we can start. We have topics, a lot of topics to look at. We have function to look at, we have limit to look at, we have continuity, we have differentiation, we have application of differentiation, we have integration, we have application of integration. Now, there is a past question that we are going to solve when we have gone midway explaining and summarizing these topics. That question, most of you in UNN would have seen those questions, that these are CBT questions, right? And they have been circulating. Usually, exam would always repeat, even if it is not exactly same way, it would repeat from those same ideas. So we'll be solving those problems. So I believe some of you have those questions already that was snapped directly from the screen. So I'll be solving them. They are high profile questions. So please help us share this video. Share it, tell your friends that Prime Concept is live. Share it. Tell them that Prime Concept is live. Register your presence. Let me check. Hit the like button. Hit the like button if you're here. Hit the like button. If you're joining us for the first time, do well to subscribe. All right? Hit the like button. All right. Now, we want to start this way. I'm looking at starting from application or differentiation. I don't know. Can you suggest where you'd like us to start from? We have function. We have types of function under function. We have limits. And then we have differentiation. We have application of differentiation. We have integration. We have application of integration. Can you drop in the comment section which area you would like us to start from so that we can go to the high impact areas for you, those areas that are still confusing? So drop in the comment. Let's know which area is best for us to start from quickly. Remember, under functions, we'll be talking of domain and range. So don't forget, we'll be talking of composition of function. We're talking of inverse of function. So tell me where you'd like us to start from quickly. Let me check by statistics. Okay. Start with function. So most people are saying function. So it means that the functions have it, right? So, all right. So we're going to start with function. At least the people that are present have it now, and I'll be summarizing it very fast. This is like one of the easiest topics in Maths 103 or Maths 102, right? Now, what is function? Very quickly, you need to understand that function is not a big deal other than a machine. Function is just, it acts like a machine. You know, a machine that takes an input and gives you an output. So any mathematical rule or any mathematical operation that takes an input and gives an output is going to be a function, right? Yeah, that is what a function is. For example, I would usually use this illustration. Say for the Nigerian people, say you want to grind egusi, you want to grind egusi, Now you have the, don't know whether they call it seeds of egusi, or don't know what's the correct English for that. But you notice that when you put it inside the grinding machine, it doesn't come out as seeds again, it comes out as what? Powdered form. So that engine is your function. The egusi in the raw form is your input, and the powdered form is your output. So in every of these things, we'll talk about input, we talk about function, we talk about output. So the official definition of a function is, a function is a rule that assigns a set of inputs to a set of outputs as an ordered pair, such that there is no repetition for the first entries in the ordered pair. Are you getting me? Yes. So a function is a rule. It takes an input, assigns that input to what? To an output, so that at the end of the day, there is no repetition in the first entry. So this is what we mean. So we have f as a function, which is a rule. You have, let's say, 1 comma 2. I hope you know this is what you call an ordered pair. So you have 3 comma 7. This is an ordered pair again. Then you have 1 5 comma 6, like this. Now, so say I have something again. Let's say you have G, and you have 1 comma 2, and you have 1 comma 4, and you have 4 comma 5. Now, if I ask you which one of these two is a function and which one of them is not a function, of course you are very correct. The first one is a function, the second one is not a function. Now, for what makes for a function is that in your ordered pair, there should be no repetition of your first entry. Your first entry is 1, 3, and 5. So once your first entry repeats, then it is no longer a function. It is just called a relation, but it is no longer a what? Function. So what makes for a function is that there should be no repetition. So if you look at this, you notice you have 1 here, you have 1 here. So because there is repetition in your first entry, it means that this is not a function. All right? Okay, it's blurry. My God. I think that is network. Let's see. Oh, wow. Let me see if I can work on it very quickly. So let me try to work on it. Give me a few minutes. Is it clear now? Okay, it's clear now. All right, all right, all right. All right, it's clear now, right? It's better now. All right, thank you. So I can move on. Thank you. All right, so thank you. So let's move on. So I should just move on. I shouldn't even waste time with much definitions. So, but what I'm just saying is that what makes for a function is that there should be no repetition in your first entry. Once your first entry repeats, it's no longer a function. If you have something like this, h equals this 1 comma 2, 2 comma 4, 3 comma 3 comma 4. And if you have something like this, is this one qualified to be a function? Is it qualified to be a function? Let us see. If there's repetition in the first entry, this is 1. There's no repetition in the first entry, so this is a function. So your major interest is that there should be no repetition in the first entry. If the second entry repeats, no challenge, it's still a function. But first entry should not be repeated. So this is also a function. I hope that is clear. Now I need you to understand that in a function, the set of first entries is what you call domain. The domain represents the set of what? First entry. While the codomain or range represents the set of what? Second entry. If somebody should ask you what are your domain of this function, what will you say? You will say it is 1, 2, and 3. So the domain, dom of h, you'd say it is what? 1, 2, 3. If they ask you what is the range, what is the range of h, what would you say? You'd say the range is what? 2, 4, 2 and 4, because you don't have to repeat, you don't have to write it repeatedly. So this is the domain. So domain are the set of first entry, range are the set of second entry. Now we have different types of function. That is our major interest. So we have types of function. Number one, which is the easiest, I will go to the major exam focused functions. So number one is what you call constant function. So number one type of function is constant function. So what is a constant function? A constant function is a function that gives a constant output irrespective of the input. The output is constant and it is usually denoted as f of x equals k. F of x equals k. That is to say, whatever the value of x is, your answer would always remain k. For example, they say, if f of x equals 2 is a constant function, find number one, f of 7, f of 0, f of minus 10. So can you tell me the answer respectively for each of these? Remember, we have to be fast with function because it's a very simple topic. So tell me, drop the answers in the comment section. Drop the answers. Drop the answers. Let me see. What's the answer? Okay. Give me the three answers. Okay. All right. So now they said if f of x equal to is a constant function, find f of 7. Find f of 7. So now what it means in this case is that in this case x is what? 7, right? Now they've told us that the function is f of x equals 2. So for a constant function, no matter what the value of x is, your answer will remain the constant. So f of 7 is still going to be 2, f of 0 is going to be 2, f of minus 10 is going to be 2. No matter what it is, your answer will remain what? The constant output. I hope that is clear to you, right? Yes, and I'm sure the video is still clear, no complaint, right? So that is a constant function. Now, what is one of the things you should know about a constant function? You should know that for a constant function, the domain of a constant function is real numbers, all real numbers. Exam will ask you this. In exam, they will tell you, just like in this case, they say if f of x equals this is a constant function. Now, even if they don't tell you, as long as f of x or g of x or h of x, as long as it's just equal to a number, it means it is a constant function. And the domain of every constant function is what? Real number. And I hope you know that another way to write real number, in case you don't want to write real number like this, another way to write it is to use open bracket minus infinity to infinity. So it's either you write like this or you write like this. I hope that is clear. Yes. Then another thing you need to know for a constant function is the range. What is the range for a constant function? The range of a constant function is what? The singleton. Singleton is just a set that contains one element. Is singleton, and that value is k. So the range of the constant function is k. So in this case, the range is 2, right? Because k is 2 in this case. So this is what you need to know for a constant function. Number 2 is what you call identity function. Identity function is usually denoted with ID of x, like this. So this is usually how we denote identity function, right? Now, what is an identity function? An identity function is a function that returns the same input. It's just like when you stand in front of a mirror. You that is standing in front of the mirror, you are the input. And when you look at the mirror, you see your identity. What you have in the mirror is what? Is your output. So it means that whatever you place in front of that mirror, if you bring this marker and place in front of the mirror, you would see the marker. So identity function returns whatever you give to it. If you give it 2, it will return 2. If you give it 3, it will return 3. If you give it 4, it returns 4. That is identity function. So you have, for example, they say identity function of x. This is actually how it is defined. Identity of x is equal to x. This is identity function. So they say find ID of 2, find ID of, let's say, 9, find ID of 0. So not to waste time. Now in this case, what is x in this case? X is 2. So it means you're putting 2. So what is the output going to be? It's going to be 2. In this case, what is the output going to be? It's going to be 9. In this case, what is the output going to be? It's going to be 0. So identity returns whatever you give to it. It returns it. So number 3. If you have a question as I'm moving very fast, you try to drop your question. So number 3 type of function is what we call absolute value. Absolute value, or another name you can call absolute value is what? Modulus function. So it's either you call it absolute value function or you call it what? Modulus function. So we have a mathematical way of defining absolute value, which is going to be helpful to us as we progress in this course. So the mathematical way, usually absolute value is denoted with 2 straight lines like this. So, and the mathematical definition, absolute value is defined piecewisely. So absolute value of x returns x whenever x is greater than or equal to 0. It would return x. It will return the value of x. I will explain this, but you don't even need to know this to understand absolute value. Now, absolute value returns negative x whenever x is less than what? 0. Now, in mathematics, when you see greater than 0, it means you're talking of positive numbers. When you see less than 0, you're talking of what? Negative numbers. So you should understand. So what absolute value is telling you is that whenever the values of x are positive, it means that, and when you put it inside absolute value, the answer would still be x, that positive answer. But whenever the values of x are negative, then it will be negative of that x, which becomes positive. Now, this is what we mean. If they say find absolute value of 2, find absolute value of 2. Please say I want to use this to explain it to you. They say find absolute value of 2. Who can tell me what x is in this case? X is actually equal to 2, right? X is equal to 2, so, and 2 is positive, which means in this interval. So it means that absolute value is equal to x. Remember, when x is positive, your answer is x. So absolute value of 2 is equal to x. Remember, x is what you have inside. So it means the absolute value of 2 is going to be 2. Now, I'll still explain better. Let's say you have absolute value of -4. Please, you can tell me what absolute value. What is x in this case? Remember, x is what you have inside the absolute value. So our absolute value in this case is -4, which is negative, which is in this case. So when x is negative, absolute value is negative x. So it means this is going to be negative of x, right? Which is equal to negative. Please, what is our x now? Our x is -4. So it means that the absolute value minus times this becomes what? 4. Now, don't mind this kind of solving, but I believe some of you understand what I explained here. But in case you don't understand, don't worry yourself. Let me explain it in a layman's language. In a layman's or a market woman's term, what absolute value does is that absolute value makes every negative number to come out positive. It makes every positive to still be positive. It makes every negative to be positive. It doesn't change the value. It only makes it to be positive. So in a short way, if you have absolute value of minus 10, what will it be? To be 10. If you have absolute value of minus 50, what will it be? It will be 50. If you have absolute value of 29, what will it be? It will still be 29 because it's already positive. If you have absolute value of 0, what will it be? 0. Absolute value does not change the answer. It only changes the what? The sign. I believe it is very clear to you. Now, did I tell you the domain of identity function? I don't think I mentioned it, so I will mention it now. I told you the domain of constant function. So let me mention domain of identity function. For identity function, the domain is actually all real numbers. Don't forget, they will ask you these things. This OBJ you're writing, so take note of these things. The domain of identity function is all real numbers. Remember, domain is everything you can give to that function. Now you can give anything to a function. So the domain is all real numbers. What about the range for identity function? The range, remember identity returns the identity, so the range is also what? All real numbers. So don't forget, for identity function, the domain and range are what? Real numbers. And what about absolute value? For absolute value, what is the domain of absolute value? The domain of absolute value is what? All real numbers. All real numbers. That is the domain. What about the range? The range of absolute value. Now notice that absolute value only gives you an output that is what? Positive. An output that is what? Positive. So it simply tells you that the range of absolute value is all real numbers but restricted to the positive part. So it means that the range of absolute value is positive real numbers. Positive what? Real numbers. While the domain is both negative and positive, right? I believe it is clear. So let's look at the fourth type of function. If you are still following me at this point, please say move on. Let me see. Say move on. If you are still following me, say move on. If you are still following me, say move on. Make sure you hit the like button. If you are still following me, say move on. So, all right. So we want to look at, please take note of this thing you are seeing. We're going to use it when we get to limit. We're going to use it in some other parts. Take note of this. That absolute value returns x when x is positive. It returns negative x when x is what? Negative. Take note of that definition, right? Number 4 type of function is what you call signum function. Signum function is denoted as SGN of x. So whenever you see this in your math, it means they're talking of what? Signum function. Now, mathematically, we define signum function this way. We define it piecewisely. So it means that signum function would return 1 whenever x is positive. It returns 0 whenever x is 0. And it returns minus 1 whenever x is what? Negative. So this is the definition of signum function. And it is very simple. So whenever you have, for example, e.g., they say find signum of 200. What you would ask yourself, 200, is it positive? Yes, if 200 is positive, it means your answer would always be 1. So signum of 200 is 1. If they say find signum of 1000, you ask yourself, is this 1000 positive? If the answer is yes, then it will always be what? 1. So signum of any positive number is 1. What if they ask you signum of 0? What will it be? It's going to be 0. What if they ask you signum of minus 95? What will it be? And you ask yourself, this is a negative number, right? Yes, because it is negative, the answer becomes what? -1. So whenever you have a negative number, signum returns -1. Is it clear to you? Yes. Somebody would say, what is the domain of signum function? What is the domain of signum function? Now, the domain are the things you can put. Remember, if you look at this, we don't have restriction. I can put 200, 1000, 0, -95, anything. So it means the domain of signum function, the domain of signum function is what? All real numbers. The domain of signum function is what? All real numbers. I can use anything, right? Yes. What about the range? The range of signum function. The range are the possible outputs. And if you notice, signum only have 3 outputs, which is either 1 or 0 or -1. Are you getting me? Yes. So it means that the range of signum function, you usually start from the lowest number, which is what? -1, 0, and 1. So the range of signum function is -1, 0, and what? 1. So quickly, if you are still following me, say move on, because I'm done with signum function. I want to look at Heaviside function. Hey, my God. I need to fix this. Let me fix this. Give me a few minutes to fix this. All right. So sorry for the interruption. Let's see those are still there. Sorry for the interruption. Okay. Yeah. No, it's the wall that is actually a weak wall. All right. I'm fully ready. So I want to move on. So we want to look at number 5, I think, Heaviside function. Heaviside function. Now, in your maths, anytime you see small letter h, they are not talking of Heaviside. But the moment you see capital letter H of x, we are referring to what? Heaviside function. We are referring to what? Heaviside function. Are you following me? Yes. Now, what is the definition of Heaviside function? Heaviside function is also defined like this, piecewisely. It returns 1 whenever x is greater than or equal to 0. It would return, whenever x is greater than 0, it returns 1. And then, whenever x is less than or equal to 0, it returns what? 0. So this is your Heaviside function. Alright? Yes. So whenever x is positive, it gives you what? 1. Whenever x is negative, take note, whenever x is negative or 0, it gives you what? 0. Are you following me? Yes. Now, for example, say you have Heaviside of 50. 50 is a positive number. So when it is positive, what will your answer be? 1. So it means you have 1. If I ask you what is heavy side of 99, what would the answer be? 99 is positive. So for positive, you always get what? 1. If I ask you what is heavy side of 0, heavy side of 0 is what? You are correct. Is what? 0. Because whenever x is less than or equal to 0, your answer is 0. Now, if I ask you what is heavy side of minus 39, what will you tell me? You tell me that this is equal to 0. Why? Because heavy side returns 0 whenever your x is negative or 0, it returns 0. What is heavy side of minus 51 or 59? It is still what? 0. I believe heavy side is very clear to you. Now let me do the last type, then let's take exam questions. All right? Now, okay, you may ask, what is the domain and range for heavy side function? What is the domain and range for heavy side function? Domain of your heavy side function. I need you to guess. Can you guess? Can you get? Not guess, because you're a mathematics student. So tell me what you think. I'm waiting for your answer. I'm waiting for your answer. Divine praise, are you there? Drop your answer very quickly. I'm waiting. Uchechi, are you there? Drop your answer very quickly. I want to see your answer. Any answer yet? Okay.
All real number.
Okay, domain, all what? Real numbers. Domain is all real numbers. You are what? Correct. The domain is all real numbers. What about the range? No answer for range. Nobody knows the range. Of course, your range is going to be what?
0,
0 and 1. You are very correct. So your range is going to be 0, 1. Remember, your range is your what? Output, which is 0, 0 and 1, or 1 and 0. That is your range. So this is the answer. Let's look at the last type of function very quickly. So the last type we want to consider is what we call greatest integer function. Greatest integer what? Function. From the word greatest, it explains it. Greatest and integer. Do you know what integer is? Integer means whole number. Integer means what? Whole number. So when you say greatest integer is referring to the largest integer that is less than or equal to what? X. It is the largest integer. It is the greatest. It is the biggest whole number that is either equal to X or less than X. Right? For example, okay, let me just give you the steps that would help you so that I can now explain. So in order for you to do greatest integer, all you need to do, number 1, is convert to decimal. Convert to decimal. Usually they will give you very easy numbers. So convert to decimal. That's number 1. Number 2 thing you need to do is place on a number line. Place on a number line. Then number 3, finally, move to the nearest integer towards the left. Move to the nearest integer towards the what? Left. Now let's take a simple example. Simple example. Say you have, this is the symbol for greatest integer, a square bracket. That's the symbol. So when you see something like the greatest integer, you see greatest integer of, let's say, 1.5. So they want us to find the greatest integer. Is a square bracket. That is the symbol. Whenever you see square bracket and only one number, it means you're talking about greatest integer. So they want us to find greatest integer of 1.5. Now step 1 is not necessary again because it's already a decimal. So step 2 says place on a number line. So I'm going to place 1.5 on a number line. So this is what I mean. On a number line, I have 1, I have 2, I have 3, and so on. So you obviously know that 1.5 is going to be between 1 and what? 2. So this is where you have 1.5. I hope that is true. Now step 3 says move to the nearest integer towards the what? Left. So what is the nearest integer towards the left? If I move, the nearest integer towards the left is 1. So it means that the greatest integer is what? 1. I hope that is clear. Yes. So if I say find greatest integer of minus 0.5, what will it be? I'm going to use my number line. Now I have 0, I have minus 1, I have minus 2, and so on. Now, you know that minus 0.5 should be in between here. I hope you know that. Should be in between 0 and minus 1. You know, right? Now, moving to the left, the next whole number you have moving to the left is what? Minus 1. So it means the greatest integer is what? Minus 1. I hope this is clear to you. Yes. What if I ask you, I want to rub this. What if I ask you to find the greatest integer? So I ask you to find the greatest integer of minus 3 over 2. So do it quickly and tell me your answer in the comment section. Do it. Drop your answer in the comment section. I'm waiting. God's will says 2. Okay. God's will says 2. Uguani said is minus 2. Who else? Noah said is 1. God's will says minus 2. Chimeri says minus. For the concept, obviously, is not clear to you people, as I'm seeing different answers. All right. Okay, let me answer that. Now, you have this. First, you should notice that this is same thing as minus 1.5. 3 over 2 is same as 1.5, right? Then you have a negative. And if you place on your number line, you have 0, you have minus 1, you have minus 2, and so on, minus 3, and so on. So minus 1.5 is going to be between this, Abby? It's going to be between this. So this is where you have minus 1.5. So when you move to the left, your answer becomes minus 2. So the greatest integer is minus 2. Now drop the answer to this 2. What if I ask you to find the greatest integer of 4, and then find the greatest integer of 0? So, and then drop the greatest integer of minus, let's say minus 2. So tell me the answer. Type the 3 of them, and then I want to give you more serious exam kind of questions now. So I'll be solving from that past question. Those of you that have it, I'll be solving from it. Those questions were gotten from the screen, so I'll be solving from those things. So these are real questions, the way exam will be. So who has the answer to these ones? Any answer yet? Okay.
4 to 0.
4 to 0. By who?
402.
420.
No, 402.
402.
Someone said 313.
313. My God. Any other
Minus
answer?
3.
My God. Let's solve it.
0.
It's okay. Now, anytime you are dealing with whole numbers, your answer is automatically that whole number. What greatest integer seeks to do is it seeks to make a number to be a whole number. So if you already have a whole number, it means that becomes your answer. So the greatest integer of 4 is still 4, is already a whole number. Greatest integer of 0 is 0. Greatest integer of minus 2 is still minus 2. These are already what? Whole numbers. So don't forget. Finally, what is the domain of the greatest integer function? This is how you write greatest integer. What is the domain of greatest integer, and what is the range of greatest integer? Who knows the domain? The domain, of course, like you have always known, is what? All real numbers. All real numbers. What about the range? Tell me what the range would be if you get it. If you get it, my God. Tell me what the range would be. Any answer? for range?
When is all real number?
Okay, range. No answer for range. Of course, now one of the things you should understand is that greatest integer likes to give you an output that is an integer. So it means that the range of greatest
It
integer
says set
is
of
what?
integer.
A set of what?
Integer.
Integers. So the range is very clear from the name. Set of integers. Remember, integers are positive and negative whole numbers. So don't forget, these are the subtle questions exam will ask you. And let's take a look at this one that came out in this particular year. I think this should be last year. This should be last year or last 2 years. Now, I hope I can rub this now. Yes. So let's solve this. I'll give you 30 seconds to attempt it yourself. The question says evaluate x raised to power 4 minus signum of x plus 6 divided by 2. Evaluate it at x equals minus 3. So I'm giving you 30 seconds to solve. Let me see if we have another one there. Giving you 30 seconds to solve this.
It's okay, someone answer.
Somebody has an answer. Okay, tell me.
They said 44.
44. Okay, let me write it. 44. By who?
By Ugwani.
Ugwani, thank you. Thank you, Ugwani. So who else?
No, another answer.
Okay, I have another question here. I have another one. Okay. Now let's solve this together quickly. This x raised to power 4 minus signum. Make sure you are done solving. Just follow me. X raised to power 4 minus signum of x plus 6 over 2. They said wherever you see x, please replace it with what? Minus 3 and evaluate it. So it means I'm going to write minus 3 raised to power what here? 4. Because I'm replacing this x with minus 3 raised to power 4. Then minus signum of what is x? X is minus 3 plus 6 divided by 2. Please, what is minus 3 raised to power 4? I hope to remind you that you will not be using calculator for this exam tomorrow. So everything you're doing now, you're doing from your what? Head. So now, anytime you have a power and your power is even, it will always fizzle out the negative sign. So once your power is even, it means negative sign will always disappear. So by virtue of 4 as our power, which is even, it means there will be no negative here again. This negative will disappear. Right? Yes. So what is now 3 raised to power 4? 3 raised to power 4 is 3 times 3, which is 9. So 9 times 9, which is 81. So 3 raised to power 4 is 81. Minus signum of minus 3. Remember, what you have minus 3 is negative. And whenever you have negative, signum returns minus 1. So it means signum of minus 3 is what? Minus 1. Notice I am using bracket. Why did I use bracket? Because you have minus here. So don't conflict it. Signum of a negative number returns negative 1. Then plus what? 6 divided by 2. Now, you're going to have 81. Minus is plus 1 plus 6 divided by 2. 81 plus 1 is 82. 82 plus 6 is 88. 88 divided by 2 is what? 44. So, Ugwani got it. Congratulations. You're going to do very well tomorrow. All right? Yes. Now, let me give you the next one. So, quickly screenshot it. Let me give you the next one. All right. Can I move on? If you are done, say move on. If you are done, say move on. If you are done, say move on. Let me drop the next question. To solve this, solve this. I'm bringing all these things from those past questions. Some of you have seen them. They said if f of x equals greatest integer of this minus x, evaluate f of minus 1.9. So this is the question. 30 seconds to solve. Let me look for more and we move on. 30 seconds to solve. 30 seconds to solve. 30 seconds to solve. I have another one, still from the same year. We must trash all of them and then we move on. Any answer? Tell me.
0.9.
0. Point what?
9.
0.9. All right, I'm going to check. Who else? Any other answer? Who gave this?
God's will. Okay.
God's will. Okay. Any other answer? I think I should solve and save time. Now, they said if f of x is equal to greatest integer of x minus x, evaluate
Another answer.
f of minus 1.9. Which answer again? Who gave?
Minus 3.9. 3.9.
Minus 3.9. Who gave the answer? All right, let's solve. Stop solving and follow me now. Let's solve together. So what this thing means is that wherever you find x in this function, please replace it with what? Minus 1.9. Make sure you're following me. So you have x, I'm replacing x with minus 1.9 equals greatest integer in place of x, I'm putting minus 1.9, then minus into minus 1.9. Why did I use bracket? Because I have a minus here. This minus is what you're seeing here. Then x is minus 1.9. That is what I've done. Notice this minus is what you're seeing. X on its own is already minus 1.9, right? Don't make the mistake. Now, we want to find greatest integer of minus 1.9. If I draw my number line, I have 0, I have minus 1, I have minus 2. So 1.9 should be between 1 and 2. You should know that. So this is minus 1.9. It means the greatest integer is going to be minus 2. So greatest integer of minus 1.9 is going to be minus 2. Now, minus times minus is what? Plus 1.9. If you do this subtraction, 2 minus 1 is going to be 1. Right? 2 minus this is going to be, okay, this is going to be minus 0.1. Yeah.
That's the answer.
Minus 0.1 is the answer. Anybody? Did anybody get it? Tell me who got it. The answer is minus 0.1.
Sochi green light.
Sochi green light. You got minus 0.1.
0.1.
Thank you. That's correct.
He's the only one that.
Okay. So screenshot. Let me drop the last question and then move to the next topic. All right. John, thank you. Noah, thank you. God's will, thank you. Okay. But some of you are typing your answer after you have seen mine. I hope that is not what you are doing. Can I move on now? All right. I should move on. So next question is this. So find the value of absolute value of x plus 1 divided by 3x at x equals minus 1 over 2. 30 seconds. 30 seconds to solve this. I think after this I'm done with types of function. I'll move to composition of function, then inverse, then I'll look at domain and range. We have to be fast, so we have a lot to do. A lot. Any answer? Any answer? Any answer? You have 5 seconds to go. Any answer?
1 over 3.
1 over 3. Who gave the answer?
Chineme.
Okay.
Another one say minus 3 over 2.
Minus 3 over 2.
Another one
Who
minus
gave me
2 over
this?
3. Noah.
Noah. All right.
And
So
that one is -2/3.
-2/3. All right, let me solve. It's okay. Let's solve. They say find the value of this. I hope you notice that this is absolute value. And they say wherever you see x, please put -1/2. I have absolute value of -1/2 plus 1 divided by 3 into -1/2. This is what I have. So please, if you have -1/2 plus 1, all you need to do here, just say 2 times 1 minus 1 is what? 1 all over 2. I repeat, 2 times 1 is what? 2. 2 minus 1 is 1, then over the denominator. So it means that we're going to have absolute value of 1/2 from this side, divided by 3 times -1/2 is obviously -3/2. Please, what does absolute value do? Absolute value brings out negative numbers as positive. If the numbers are already positive, to still bring them out as positive. So absolute value of 1/2 is still 1/2 divided by what now? -3/2. If I do this thing simply means 1/2 divided by -3/2, which means 1/2 times -2/3. That's what it means. So 2 can go. I have what? -1/3. So nobody got the answer. My God.
Okay. Oh wait, someone got the answer.
Who got the answer?
That's Sachibike maths class.
Huh?
-1/3.
Who is the person?
Sachibike maths.
Sachibike. Okay. Sachibike. Well done. You did well. So tell me to move on. I want to move to the next part now, which is composition. Okay. Okay, now if you're good, if you're just joining, no cause for alarm, you flow. We have so many other topics. But please hit the like button, comment, subscribe if you are yet to subscribe. Hit the like button. Hit the like button. We have 46 people and just 23 likes. So hit the like button so you don't forget. Hit so that I can move on. Hit the like button, please. Hit the like button. Thank you. So you don't forget. Hit the like button. We have 46. Make it up. Make it up so you don't forget. All right. That is your way of supporting our channel. It's not easy. Help us. Subscribe if you are joining and you are yet to subscribe. So you help us hit the subscribe button. All right. Now, we want to quickly look at composition. Composition of function. Please notice that I'm trying to be very fast. But if at any point I'm too fast, draw me back. All right. So I'm trying to be very fast with the explanation because of the many topics we have to learn. So composition of a function simply means imputing one function into another function. And how do we denote? We would usually denote with a symbol, not a circle, small circle. So if you see something like this, this means F composition G. It means you are putting G into F. You are putting G into what? F. And this is like the easiest thing you will do in maths, trust me. Now let me give you an example very fast. Say you have, they say f of x is equal to 2x plus 1, and they say g of x is equal to 7x squared. They say find question 1 f composition g, question 2 g composition, right? So let's do it. So what you're just doing is that you want to put g into f. Now anywhere you find x in f, please replace it with g. Now, what is my f? My f is 2 times x. Instead of writing x, I'll put g plus what? 1. Anywhere I see x here, I'm putting g. So 2g plus 1. Now you know that g is given to you as 7x squared, so you can now replace it. So 2 into, instead of g now, 7 then plus 1. So if you expand this, what would this give you? 2 times 7 is 14. x squared plus 1. So this is the answer for f of g. So with this, can anybody do g of f? Then I will give you from the exam questions. I have questions under composition there. But I'm done explaining composition. Anybody? G of f, I'm waiting. Anybody that solved g of f? Do it. Remember, you're writing this tomorrow. So be very active, be solving, be seated with your pen and your paper. Make sure you are solving. Any answer? All right, let me solve. So, want to find number 2, want to find g of f. It means that we are putting anywhere we find x in g. Well, now this is my g. This is my g. So I have 7. My 7 instead of x, I'll say 7 f squared. So what do I have? 7. What's my f? My f is actually 2x plus 1 all squared. Let me finish. 2x plus 1 all what? Squared. I can leave it this way, or I can decide to expand. Which way? So, any answer? Did anybody solve?
Ebubechigo. I
What
think
did you get? Is this same
yes,
So
he
got
got
it.
it. Yes. And
Remember, you can expand it, but we don't have
also,
time to do that.
one kasi.
Okay, same thing.
Yes.
Okay, so it's good. Now, I want to bring from this so that you can just be solving realistic because there's any special thing here. Okay, I have this. Let's solve this from that same past question. So say you have, they said if f of x is equal to root x and g of x is equal to 2x, find find g composition f of 4. So this is what the question is asking us to do. So can I give you 30 seconds or I should solve? I think you would need to attempt this. This is a typical exam question. So who has the answer? Giving you 30 seconds, solve this. So, okay. We'll go and say -3, Christopher, -3. Okay, can't hear you. I hope it's only from your side, King. Okay, I think I should solve now. Your answers are flowing. So let's do it together. At this point, I need to stop so that we'll do it together. Right? Then you verify your answer. Now, whenever you see, they said find g of f at 4. So just ignore this. Find g of f. When you are done, wherever you now see x, you now put 4. So for now, let's do g of x. G of x simply means I'm starting with g. And g is 1 minus 2. Instead of x, I'll put f. So g is 1 minus 2. What is my f now? Go and look for x. F is square root of x. So this is my g of f. But will I stop there? No. They said g of f when x is what? 4. So it means I'm going to have 1 minus 2 root what now? Root 4 because x is 4. So I'm putting 4 for x. So what do I have? I have 1 minus 2. Now, what is root 4? Root 4 is 2. So remember, it's multiplying 2 times root 4, and root 4 is 2. So I have 1 minus, this is where board mass comes in. Some people will go and say 1 minus 2 first. No, minus 2 times 2 is what you're going to do. So you have 1 minus 4 is minus 3. I believe some people missed it here. So some people will say 1 minus 2 is minus 1, and minus 1 times 2 is -2, you will fail it. So in board mass, you attack multiplication first. So the correct answer is -3. And I believe most of you got it. All right? Yes, that is the concept behind composition. So let me get into inverse function. Inverse function. After inverse, I do domain and range, and I'm done with function. But domain and range is big. Inverse function. Inverse function. Now, inverse of a function is denoted as this. Now, you notice it has f to power -1. So there is -1 in the power. This is inverse. Please, f to power 1, this is not inverse. So this is not what we are dealing with. No. Inverse is f to power -1. When you see f to power 1, this is called derivative. We don't need it for now. This is inverse. How do you solve inverse? I'll give you steps for solving inverse. Steps. Number one, change f of x to y. That is to say, replace f of x with what? Y. Number 2, make x the subject. Make x. So in inverse, basically what you're doing in inverse function is subject formula. So make x the subject formula. Right? And then number 3, replace x with f inverse of x and y with x. So take a look at these steps very well. I'm going to apply it now to an example, and we still have problems from the exam again. So my aim is to solve all the problems there as I teach the topics. So what it means is that this class may extend up till 8 p.m. Yes. So let's take an example. Let's say we have f of x. This is how it will come. Say you have f of x equals 2x plus 1, comma, find f inverse of x. This is the question. I'm going to apply these steps to it, right? Yes. Remember, inverse is simply making subject formula. So what is step 1? Step 1 says replace f of x with y. So I have, instead of this, I'll just say y equals 2x plus 1. So that is step 1. Step 2 says make x the subject formula. So if I want to make x the subject formula, first thing I'll do is I'll say y. When I bring, remember this plus, when it crosses, it becomes -1 equals what? 2x. So what will I do? I'll divide both sides by 2. So if I divide by 2, divide by 2, this will go. Then I have that x is equal to y minus 1 over 2, or you can simply say y over 2 minus 1 over 2. It's still the same thing. Is that the last step? No. The last step says replace x. This is the last step. Replace x with f inverse. So it means I would say, instead of x, I would say f inverse equals y. Or let me start here. Equals y. Now I'm replacing y with x. So it equals x minus 1 over 2. Or I can simply say x over 2 minus 1 over 2. So that is my answer. If it is clear, say move on. If it is clear, say move on. If it is clear, please say move on. If it's clear, say move on. My God. Tochi said, I am confused. Can I give more example to make you understand, Tochi? I think it will be better. So now let us say I want to use another example so that at least others will still be benefiting while you're benefiting. Now let us say you have f of x equals x squared plus 7. Find F inverse of x. So let me solve so that we don't waste time. I need to be fast. So the first step is I'm going to replace f of x with y. So it means I'll say y equals what? X squared. Next step says make x the subject. So I'll have y, when this crosses, becomes minus 7 equals x squared, right? And remember, I'm going to say that x squared is equal to y minus 7. Abi? Yes, to remove this square, what will I do? I'll push it to the right as square root. So it means you have x equals square root of y minus 7. Now the final step says replace x with f inverse. Don't forget. So it means instead of leaving my answer this way, this x, I will write it as f inverse because that is what I'm looking for. But if I leave it this way, I'm also wrong. So I will now say instead of y, I will change this y to x minus 7. So it means this is my final answer. But one of the things you should know is that you would see this kind of thing in the option. And some of you would smile and say, Kai, don't know that UNN don't know how to set difficult questions. You will now take it. And when you come out, you're asking your friend, guy, what is number one? The guy says number one is A. He will say it's a lie, it's B. When you ask two people, they now tell you that it's A. You now know you made a mistake, but it's not your portion. So be very careful. So when you reach here, remember to replace X with F inverse. And remember to replace Y with what? X. I hope the concept is clear. Yes, now let's take problems. From I still have problem. Okay, let me give you under exponential so that you would also see. Before I go to the exam. Now, if this thing I've explained is clear, please say it is clear so that I will know. If I move to the other part, say it is clear if it's clear to you. Please tell me so that I will know whether I should move to an advanced part. Tell me that it is clear if it is clear. Tochi, I believe it's clear to you now. Any comments? Is it clear? All right, so let's take this. Say you have f of x equals exponential x plus, why am I always doing plus, minus 4? So find f inverse of x. Can I allow you to attempt this? Can I allow you to attempt this? Maybe 30 seconds. Tell me the answer. I'll give this and one more and I'll move on. Tell me the answer.
I think we should give
All right, I think I should solve now, right? Yes. Okay, it's clear. Okay, thank you. So somebody has answer. All right. So let me solve it quickly. And let's do it together. Stop so that we can do it together. This is exponential. I need you to know one of the things that kills exponential, one of the things that fights exponential is lim, right? Yes. Now let's do quickly. F of x will be replaced with y. So you have y equals exponential x minus 4. That's the first thing you do. And the next thing is to make subject x the subject. So I have y. When minus 4 crosses, it becomes plus 4 equals exponential x, right? Yes, so it means you can say exponential x equals y plus 4. Now, anytime you have a power and you want to bring it down, please, and it is exponential, please use lim. Anytime you have exponential something, use what? Lim. So I'm going to take lim of both sides. Remember in maths, whatever you do to one side, you do to the other side. Now, so I'm going to say lim of exponential x equals lim of y plus 4. I'm taking lim of both sides. From log reading, power, you apply power law, x would come behind. So you're going to have x lim e, right? Equals lim y plus 4. Notice that lim e is 1. Don't forget lim e is 1. So it means you just have x equals lim y plus 4. Lim e is 1. Lim e is 1. Don't forget. Now, do we leave our answer this way? No. So I'm going to say my answer is f of x, f inverse, equals lim what? Instead of y, what will I write? X plus 4. So this is my answer. Now, can I move to domain now? Can I move to domain? Let me see if there's a question here in your past question. Please, is this clear to you? Is it clear? Okay, it is clear. Thank you. Thank you. Let me see if I have a question here. So what I have here is simple. It's just similar to what we've done. So I'm not giving it again. Okay, let's do this one. These questions I'm solving is 2024, last 2 years. So they are very important questions. I believe some of you have it. If you have it, if you know you have it there, quickly drop a comment telling us you have it so that others will know where this thing is coming from. If you have it, tell us that you have it. This is also very simple. So can you attempt this now? Attempt this. Giving you 30 seconds. Oh, see, it's not clear. I'm waiting for your answers. Lim x over 3. Okay. All right, I think I should solve. And say so can move out of this. Replace f of x with I'm changing this to y and is equal to what? 3 exponential x. So first thing you want to do is to divide to remove this 3. So if I divide both sides by 3, this would go. So I have y over 3 equals exponential x. I've told you, anytime you have exponential, what do you want to take? You want to take lim. Anytime you have exponential, what do you want to take? You want to take lim. So it means the exponential x is equal to y over 3. So I'm going to take lim of both sides. So I have lim exponential x equals lim y over 3. So notice that this is 3. Don't make that mistake. So this whole thing becomes x equals lim y over 3. Now, do we stop here? No. I'm going to replace it with f inverse, and then lim. I'm going to replace y with what? X. So this is my answer. So who got it? Let me see. Who got it? Okay. Cynthia tried. Cynthia got it. Tochi got it. Lawrence tried. Chineche got it. Okay. I think. Thank you. I love that. So now I hope I can rub this now. So I think I'm done with inverse function for the sake of our time. Can I rub? Say move on. You're good. Say move on. I think you're done. So I want to look at domain, and Domain is big, but I'm going to be selective of the areas of domain I'll look at. Because then, if you want me to every part of domain, you can still tell me, say, do it, I will do it. I'm at your command. Domain. Domain. So, can I move now? Yes. Now, what is domain? Domain, remember I told you that domain first entries of a function. So that is when we're defining domain in terms of order type. Now, of a function, the set of inputs of a function for which that function can be evaluated. Domain are the what? Set of input for which that function can be evaluated. That is to say, anything you're going to put, and when you put it, you will be able to evaluate the function. Now, with this idea, you would notice that there are two things that you cannot put in a function. There are two things that would, let me put it this way, you don't need, not even need, you don't want 0 at the denominator. You don't want 0 at the what? Denominator. So any equals 1 over x. Please, if x is 0 and you punch 1 over 0 in your calculator, what will your calculator tell you? To tell you mass error. So it means that you don't want this denominator to be 0. Now, once you remove that point, that is that thing becomes your domain. So it means that the only thing that will make it difficult for me to evaluate this function is when x is 0. So it means that my domain will be every other number except what? 0. My domain will be what? Every other number except 0. So in mathematics, how do we say every other number? We will say except 0. That is the domain of this. We're still going to learn it. So we're going to say that the domain of this is all real numbers. And how do we write it? Real numbers except 0. This is how we write. This is one of the ways we write it. Or you can even say all real numbers except 0. You can write it this way. You still have another way to write it, which I'm not going to talk about now. We can use number line. That's the next thing. But notice we are saying that for domain, you don't want your denominator to be 0. Number two thing you are always avoiding when you're solving domain is that you don't want numbers in an even root. You don't want negative numbers in an even root. For example, if you have something like square root of minus 2, can you evaluate something like this in your calculator? Never. It will tell you mass error. It means you don't want negative inside your square root. You don't want negative. We say even root because we're interested in square root, fourth root, sixth root, eighth root, even root. Once you have negative in even root, you cannot evaluate. But if you have negative in odd roots, such as cube root, you can evaluate it, so it's not a problem. If they give you cube root of -8, the answer is -3. But we are only talking about even root. There should not be negative in even root. So with these few points, we're now going to build on the concept of domain. Now, to make it easy for you, I'm going to explain the concept of domain in categories, and that's why I say it's going to be long. So we have about 6 different categories of domain that can help you understand to solve any problem. So I'm going to do it. Now, number 1, category 1 is not a problem. Category 1. Category 1 is polynomial functions. Polynomial function. So you should know that the domain of all polynomial function is real numbers, all real numbers. The domain of all polynomial function is what? all real numbers. Did you get it? Yes. The domain of all polynomial functions is what? All real numbers. Don't forget. So what are polynomials, in case some of you don't know what polynomials are? Polynomials are functions that are written in terms of x to any integer power. Functions that are written in terms of x to any what? Integral power. For example, if you have f of x equals 2x. This is a polynomial. What's the power of x here? 1. If you have f of x equals 7x raised to power 3 minus 4x squared and so on. This is also a polynomial because x is written to an integer power, whole number power. So these things are what you call polynomial. F of x equals 3x squared minus 4x plus 1. This is also a polynomial, right? Yes. So for all polynomials, their domain is all the real numbers. You don't need to solve anything. So once they give you this kind of things in exam, say find the domain, just tell them it is all real numbers. So how do you write it? You say the domain is all real numbers, R, or you say the domain is minus infinity to infinity. That is what all real numbers mean. Clear to you, right? Yes. Number 2 category. That is category 2. Category 2 are rational functions. Rational functions without roots. Rational functions without roots. This is like the most common category you meet in exam. Rational functions without roots. That is to say, rational functions are functions that have numerator and they also have denominator. So, but once they don't have roots, it falls under category 2. Remember, you don't even need to memorize category 1, just understand the concept I explain under each category. I can decide to even call this category 5. It doesn't matter. What matters is you know that for polynomials, the domain is real number. That is what matters. So the category order does not matter. Now, for example, say you have f of x equals, let's say, 1 over x minus 2. If you have this, they say find the domain. So what are we going to do? Now, because this is a rational function, it has numerator, it has denominator. They say find the domain. For every of this kind of category. Why? Because I told you that in domain, you are looking for those things that would affect the evaluation of a function. And the two things that affect it, one of them is you don't want 0 at the denominator. The second one is you don't want negative number in roots. So in this case, we don't have roots. So the only thing we are bothered with is that our denominator should not be 0. So let us check. It means to find this domain, I would simply say x minus 2, which is my denominator, should not be equal to 0. Because if x minus 2 is equal to 0, I'm in problem. So I'm now going to say x should not. When I cross this to this, I'll say x should not be what? 2. So it means that the domain is all real numbers. The domain all real numbers except what? 2. One way of writing it. But the exam most times don't write it this way. So let me show you the major way of writing it. Let me show you the major way of writing it. So if you want to write this another way, you take it to your number line. This is your number line. What is the number we're dealing with? 2. Put it there. So remember, we said that the domain is any number except 2. So it means we are not interested in 2. I need to understand that your domain is supposed to be from minus infinity to infinity, but we don't want to, so we need to remove 2. So it means you cannot run straight to this place. You have to run to this place. So remove this one, then run to this place. That is what your domain would be. How do we remove numbers? You remove numbers using open bracket. Open bracket means that that number is not inclusive. We did this under inequalities. Open bracket means that that number is not part of it. You don't need it. Then close bracket like this means that the number is inclusive. Now, since we don't need 2, I'm going to say that my domain is from here to here, minus infinity to what? 2. I will use open bracket because I don't need 2. union from 2 to infinity. I'll use this. So my domain is either I can write it this way or I'll write it this way. Remember, we said we don't need 2. Your domain normally, assuming 2 was not here, your domain would have been from minus infinity to infinity. Say your domain is from here, means that any number you pick from here and put in this thing, you will be able to evaluate it with your calculator. If you pick one of there is 1. So if you pick 1 and put here, you have x as 1 minus 2, which is minus 1. 1 over minus 1 is minus 1. It can be evaluated. Any number you pick, let's say you pick 3 here, you say 3 minus 2 is 1. 1 over 1 is 1. The only thing that will give you problem is when you pick 2. So it means we don't need 2. That's why we're writing minus infinity to 2. We remove it using this type of brackets, showing that we don't need it. Then from 2, we remove it. If it is clear, please say move on. I want to be sure now that it is clear. If it is clear, say move on. If it is clear, say move on. If it is clear, say move on. All right, move on. Thank you. Please, if you are joining us, yet to subscribe, hit the subscribe button. And I want you to help us share this video. A lot of you are always sharing our video. People like Noah, Uchechi, Praise, Tochi, people are always sharing, and I know. So, but please, some of you may not remember. Even now, while you are live, share it to your class group. Tell them that prime concept is handling maths 103 against your exam tomorrow. Then come back and join us. Doesn't take anything. I can give you 1 minute to do that now. Share it so that you can invite more people to this live session. It's very important to us, all right? So that more people will get to know what we are doing. Now, we have f of x equals, let's say, x plus 4 divided by x minus or x plus 3. So find the domain. So I'm allowing you to solve 30 seconds to solve this. 30 seconds to solve this, all right? All real numbers except minus 3. Right? Okay, thank you. Let's solve. Please, I want to be sure. I want to hope that most of you have helped us to share this already. So, and I appreciate those of you that have shared it. Thank you for supporting our channel. All right. Now, remember, in domain, you are looking at the denominator when you are looking at category 3, rational functions without roots. I wanted to say I said it came out, wrote a different thing. We're looking at rational functions that don't have roots. So now we're only interested in the denominator here. So I'm going to say the denominator x plus 3 should not be 0. X should not be minus 3. Right? And in this case, my domain is all real numbers except minus 3. So minus 3 is my problem. And if I want to remove minus 3, I'm going to say from minus infinity to minus 3, union minus 3 to what? Infinity. So at this point, I think I should go to category 3. I think I should move to category 3. So that is everything about this type. So for category 3, we're going to look at non-rational root functions. Non-rational what? Root functions. Non-rational root function. That is to say, functions that don't have denominator, but they have roots. For example, f of x equals square root of, let's say, x plus 5. So you have this. I hope you notice that this does not have denominator, but it's carrying roots. So whenever you have this kind of problems, how do you solve the domain? So how do you solve the domain? The domain, I'll still give you more examples from other ones, random examples. So how do we solve it now? Follow me very carefully. When we have, anytime you have roots, you need to do what we call sign tests, right? So the first step is to find the value of x. So we're going to say x plus 5 equals 0. So we're going to say x equals minus 5. This is the first step. Find the value of x by equating what you have to 0. We're going to place it on a normal line. It's negative infinity, this is infinity. What is the number? The number is minus 5. So what I want to carry out now is what we call sign tests. Now, we have two intervals in this case, right? Yes. So you can pick include minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, and so on. So in this place, I can find 0. So let me use 0. I'm going to pick 0 and replace it in this original function. If I see x, I'm going to put 0. So if I do that, I have x plus 5. So I'm going to replace x with 0. So I have 0 plus 5. 0 plus 5 what? Plus 5. The answer is positive. What I need is the sign. So it means positive. Remember, I picked 0 from this interval. So what this thing means is any number you pick from this interval and test in this, the answer will always be positive. Let me help you understand. For example, in this place, 1 is also present here. 1 is also here. If I replace x with 1, I have 1 plus 5, which is plus 6. So what it just tells you is that this interval will always be positive. So always give, this interval will always give you a positive answer. So once you have gotten this, automatically tested in positive. And which side is positive? From minus 5 to infinity is positive. So it means that my domain is minus 5 to infinity. Now, who can tell me what kind of bracket I will use here? I will use the closed bracket. Now, at this category, please use closed bracket. Why are you even using closed bracket? As long as you are not dealing with denominator, always close bracket. As long as you are denominator, I hope you know this thing is not a denominator. Yes, as long as it is not a denominator, please, what kind of bracket? You are using closed bracket. Take note, let me now explain further why it is closed bracket. If you were in our class when I taught inequalities, you would know that another way to write this using inequality, remember, when you say from minus 5 to infinity, it means you are pointing for. So, and what is this sign? This sign is what? Greater than, right? So it means your domain, you can say x is greater than minus 5. Now, greater than or equal to. Why am I saying or equal to? Because I'm dealing with closed bracket. So I'll say greater than or equal to. So it's either you see this way in the option. Please, if what I've explained now is clear, tell me, give me another one. If it is clear, please say give me another one. Quickly. If it is clear, say give me another one. Okay. Give another one. Thank you. So find f of x equals square root of x squared minus 1. Find the domain of this. 30 seconds. Quickly. Any answer? Okay. All right, you have made a wonderful attempt. So let me solve it. And after solving this, I think I'll move to the next category. Now, first, we need to solve what is inside. I know where some of you are having challenge. You have x squared minus 1 equals 0, right? You have x squared equals 1, right? Then you have x equals plus or minus square root of 1. Anytime you are dealing with square root, please always put plus or minus. So you then have x equals plus or minus. What is square root of 1? It is 1. So it means that you have two answers here. Answers plus 1 or minus 1. So what is our domain going to be? We're going to place it on the number line. This. I'm going to have minus 1. I'm going to have 1. Those are the two numbers I have. I have minus 1 and plus 1. I'll put it on a number line, and I'm going to test. I'm going to test with it, right? Yes. So let's pick in this place. We can find 0. Are you aware that 0 is here? I like to use 0 because under exam condition it saves you time. Don't go and pick big numbers. Pick 0, except when 0 is on the boundary. Then so in this interval, remember I have 3 intervals here, here, and here. So in this place I can find 0. So I'm going to replace x here with 0. If I replace x with 0, I'll have 0 squared minus 1. Please, what is 0 squared? It is 0 minus 1, which is what? Minus 1. So it means that the answer is negative. So this interval is negative. If e is negative, it means the one before it is positive. This plus, minus, and what? Plus. The sign would always be alternating. So since this is this cannot be minus, and here will also be minus, except in some rare cases which you will not meet. So let's not even go there. So this is plus, minus, plus, right? Yes, and remember for square root, we always need the positive side. So our answer is going to be what now? From negative infinity to minus 1. I'll use close brackets. Remember, always union from 1 to infinity. So this is my domain. Okay, if it is clear, tell me it is clear. I never expected this, right? Some of you never expected this, but this is how exam would be. So if it's clear, tell me that it is clear quickly. If it's clear, tell me. Is it clear? All right. I think category 4 now. Category 4. So category 4 is rational numbers. Rational function with roots at the denominator. So rational function where you have roots at only the denominator. So this category is talking about rational function. Rational functions have numerator and they also have denominator. Then, but in this case, the denominator should have a root. For example, you have f of x equal x over square root of x plus 1. So this is a rational function because it has numerator and denominator. But what makes the difference? The denominator has a root. Anytime you have root, please, you must do sign test. Anytime you have root, you must do what? Sign test. So what is the step here? The step is, remember, x plus 1 is not 0. Why are we saying x plus 1 is not 0? Because we are working from the denominator. Denominators should not always be 0. So x should not be, when this crosses, so x should not be minus 1. But remember, this is root, so we have to do sign test because it is root. So I have infinity, I have minus 1. So I'm going to carry out sign test. The sign test, I'm going to pick from this place. I can find 0 because 0 is here. So if I carry 0 and put for x here, I'll have 0 plus 1, which is plus 1. 0 plus 1 is plus 1. So it means the answer is positive. So it means that this interval is going to be positive. This will be what? Negative. So I remember for root, you always need positive intervals. So it means your domain is going to be from minus 1 to infinity. So my domain is from minus 1 to infinity. Now the question is, what kind of bracket should I use for this part? You are correct. Because this is from the denominator, remember I told you, numerators always go with closed bracket. But denominators, take note of my word, denominators must always be open bracket. Denominators must always be open bracket. Don't forget it. So this is the answer. Write it. Denominators must always be what? Denominators must always be open bracket. Can I give you another example? Yes. Let me give you f of x equals, let's say, x plus 7 over square root of 2x minus 5. So you have this. Solve this quickly. I'm almost done. So category 5 and then 6, I'm done. So I'm almost done. I've tried. Then range, I'll summarize in 2 questions for range. So some of you are dropping. I don't know why. Is it blurry? Somebody says blurry. Please, I hope it's not for everybody. Is it blurry or it's clear? Nobody yet. Okay, it's not blur. Thank you, Tochi. All right. I think I should solve it so that we can be fast. So please stop and follow me so we can be fast. We don't have time again. I think after this now, the next should be application of differentiation. Yes, and maybe application of integration, right? So and then we should be done. Because I have on my channel, I have a video under differentiation, full explanation under differentiation. And I will need to be repeating it here. So you can always go check my channel, you will see differentiation, everything in 1 hour, everything is there. So we have this. They say find the domain. Of course, we're only interested in the denominator. So it means we're going to say 2x minus 5 should not be 0. 2x should not be 5. X should not be 5 over 2. So this is what we have. we're taking this to a number line. So on our number line, we have minus this, we have this, right? And then have 5/2. Now, I want to do my sign test. Remember, in this place, I have 0. This is where I have 0. Because 5.5/2 is 2.5. So I have 0 in this interval. So I'm going to use 0 and test. So I'm going to have 2 times 0 minus 5. 2 times 0 is 0. 0 minus 5 is minus 5, negative. So it means this interval is negative. Why this interval is what? Positive. So that is what it means. Now, what is my domain going to be? My domain is going to be from 5/2 to infinity. So, and I'll enclose like this. I believe it is clear. I want to do category 5. So if you are okay, say move on. If you're okay, say move on quickly. If you're okay, say move on. Move on. Chinemeze, wow. Don't worry, you can rewatch it, right? You can rewatch it. All right. So I think category what now? Category 5, I think, right? Then category 5 and 6, the last. So category 5. I think I'm quite fast, right? Yes. So category 5 is rational functions with roots at only numerator. So rational functions where you have roots only at the numerator. Any challenge? Rational functions where you have roots only at the numerator. So you have, for example, f of x equals square root of x plus 1 divided by, let's say, x minus 7. So this is a rational function, but you have roots only at the numerator. So how do we solve this type? Still the same way. Now in this place, we have two problems. What are the two problems? One of them is that we have roots, so we don't want this root part to be negative. The second problem is that we don't want the denominator to be 0. But how do we solve it? Follow me keenly. We are going to start with the numerator. So follow me so that you understand. I will do this, solve one more, and I'll move to category 6. So please follow me so I will save time. So the step is start with the numerator. So for your numerator, you want to find the value of x. So you're going to say x plus 1 equal to what? 0. X equal to minus 1. Abi? So we have found the value of x for our numerator. Let us go for our denominator and find the value of x. For our denominator, we're going to say x minus 7 is not equal to 0. Remember why we are saying not equal to? Because it's denominator. Because if it is 0, you have a problem. So anything denominator is always not equal to, right? Yes, so x is not equal to 7. So we have the values for x from our numerator. Some people will say, but I thought we used to ignore our numerator before. Yes, but you don't ignore it when you have roots. But once there is no root, ignore it. It doesn't affect anything you are doing. I hope that point is clear to you. Yes, now let's solve. Now, since you've been able to find the values of x, what you want to do is to draw your number line. When you draw your number line, which one are you putting on your number line? The root part, which is your numerator. The root part, which is your what? Numerator. So what did I get as x? I got minus 1. So that is what I'll be using to carry out my sign test. I want you to be following me so that you understand what I'm explaining. So I'm using that, right? Yes. So what am I going to do? I'm going to carry out my sign test. So in this place, of course, you know I can find 0 in this interval. There's 0 here. So if I put 0 for x, let's see what it would give us. Remember, I'm using numerator to do the sign test. I'll pick 0, put for x. I have 0 plus 1. 0 plus 1 is equal to what? Plus 1. So my answer is positive. So it means this interval is positive and this one is what? Negative. Now I'm not done. See the very important step now of this. The important step now is that you're going to pick 7 and look for which interval 7 would fall. Let us see. 7 would fall into which interval? 7 would fall here. So it means I have 7 here. Can you see that 7 falls into this place, not here? So it means if I want to write my domain now, watch me. Because 7 fell into the positive interval, it means your domain is going to be from here to 7 and from 7 to infinity. So what is my domain? My domain is -1 to 7 union 7 to infinity. So why I left it open is I want to ask you, what kind of bracket should I use? It's very simple. Remember, -1 is coming from where? Numerator. So numerator must always be closed bracket. 7 is coming from where? Denominator. Denominator must always be what? Open bracket. Union 7 again, open brackets. Ha! Is this clear? I believe it is absolutely clear. So if it is clear, tell me it is clear. But I'm going to solve another example anyway. But if this one is clear, say clear, but solve again. Thank you. If it's clear, say clear, but solve again. If it is clear, say clear, but solve again. All right. All right. All right. So you have next question. This time you are attempting it. Now say I have f of x because square root, okay, square root of x over 1 plus x. So solve this. Let me see those that are very smart. Do it very fast. 30 seconds. All right, nobody has an answer yet. Okay. Nobody has an answer yet. Okay, Noah. Noah say let's do differentiation. So you don't want us to finish this one again. Okay. All right. So now this and then the last part. So we start with the numerator. The numerator is x equal to 0. Remember, x, you don't have anything attached to it, so you just say x is 0. So the value of x is 0. Your denominator, this is our numerator. Our denominator is 1 plus x, not 0. X not equal to minus 1, right? Yes. So we do our sign test like this. A sign test using the numerator, which is the point 0. So it means this time we're not going to carry out sign test using 0. So we're going to use something else. Obviously, anything you use is very clear. So we want to pick a number from this interval. Some of the numbers you find there will be 1, 2. So let's use 1. If you put 1 here, you have 1, which is still positive 1. If you put 2, it's positive 2. So it means obviously this place is positive, here is negative. Exactly. Yes. Now you now ask yourself, where does minus 1 fall? Right? Minus 1 falls here. So this is where minus 1 falls. So minus 1 falls into the negative part that you are not interested in. Remember, you are only interested in positive side. And minus 1 falls into the part you are not interested in. So it means it has gone like that. It is gone and forgotten. So your answer is going to be from 0 to infinity. So your answer is 0, infinity. So remember, 0 comes from numerator. So you use it. So it seems almost everybody got it and the concept is clear. So let me do the last category. Category 6. Not even the last, second to last. Category 6. So what is category 6? Okay. Category 6 is rational function. Rational function with roots at numerator and denominator. That's category 6. Rational function with roots that covers up and down. That's what this one means. So for example, you have f of x equals roots square root of x minus 2 over x plus 4. Please let me refill my ink. So I'm presuming that somebody should have even attempted that question on the board already, but nobody has even dropped answer. I think you are waiting for me to explain it. So for this, because numerator and denominator are covered with roots, it means you need to find the value of x at the numerator, which is x minus 2 equals 0, x equals 2. For denominator, you say x plus 4 equals 0, x equals minus 4. Sorry, not equal to this. So these are the values of x, 2 and minus 4. Now notice that both of them are inside the root. So you're going to use both of them for your sign test. So you place them on your number line like this. So you have minus 4 and then you have 2. So you are going to use the both of them for your sign test because both of them are inside your root. So and when you're carrying out your sign test, you're carrying out your sign test using x minus 2 over x plus for everything like this. And let's pick where we have 0. We have 0 in this middle place. I'm sure you know. We have 0 here. So if I pick 0 and replace it here, I would have 0 minus 2, which is minus 2, 0 plus 4, which is what? Plus 4. So your overall answer you can see is negative. So it means that this place is negative, here is positive, here is what? Positive. Remember, root always needs positive answer. Now I want to write my answer. My answer is going to be minus infinity to minus 4 union 2 to infinity. And the question is, what kind of bracket should I use? I told you numerator is closed bracket, denominator is open bracket. So minus 4 comes from denominator, open bracket. 2 comes from numerator, closed bracket. And that is the answer. So I think with these few points of mine, I want to add category 7. And category 7, you don't need to solve actually. That's what I want to mention. So what is category 7? Category 7. So for category 7 are root function, odd root functions. Category 7 is what? Odd root. So if you have f of x equals, let's say, cube root of x plus 1 over x minus 2. If you have this, remember this root is odd. Anytime you have odd roots, they say find the domain. Treat it as if there is no root there. So it means if I want to solve it, I will rewrite this question and I will not write it with root. So if I'm to treat this as if there is no root, it means I would say f of x is equal to x plus 1 over x minus 2. This is how I'll say it, right? And then when you see something like this, how do you find the domain of this thing? This falls under category 2. So it means if you want to find the domain of this, it's going to be all real numbers except 2. So it means when you see odd roots, remove the root and look at it. Which category does it remind you? Solve it as that category it reminds you of. This reminds you of category 2. And in category 2, you only need the denominator. Solve it and find the domain. That is the answer to this. Is that clear? Yes. So now what about range? I'll take only one problem in range, or let's say 2 problems in range, because I need to move out now. So for range are the set of outputs for which a functions will be obtained. Range are the set of outputs you would obtain when you evaluate a function at its domain. That is range. In a simple term, range are just the output you would get from a function as range. Now, the usual kind of problems you will see in your exam is something like y equals 1 plus 1 over x, right? Yes, you would see something like this. These are the usual kind of things you will see. And when you see this kind of problem, you want to find the range. All you need to do in range is make x the subject formula. Find the domain of that new function. The domain of that new function is the range of the original function. This is what I mean. This is what I mean. Now they say find the range of this function. First step is make x the subject formula, right? So what it is going to be, I'm going to have y, when this 1 crosses, it becomes y minus 1 equals 1 over x, right? Now, see what I'm going to do? I'm just going to say that okay, stopped working. I don't know. I just noticed it. Where did you stop hearing me, please? Did you hear when I say make x the subject formula so that I will know where to continue that? Okay, because we say I thought my data, even me, I thought my data finished. I hope my own has not finished. Because I wanted to recharge with another phone, but I just realized it's going through again. So where did you stop hearing me? Did you hear when I said make x the subject formula? Okay. All right. Now what I'm saying is that for range, first step, make x the subject formula, which I have achieved. Second step is find the domain of your function, of this new function. The domain of this new function is the range of the original function. That is just the idea. So what is the domain here? For this kind of thing, I've taught you how to find the domain. The domain is when y minus 1 is not 0, when y is not equal to 1. So it means that the domain is all real numbers except what? 1. So invariably your range of this function is all real numbers except 1. Your range is all real numbers except what? 1. That is your range. Your range is the domain of this. The range of this is the domain of this. So get it. First step, make x the subject formula. When you make x the subject, second step, find the domain of your new function. The domain you have gotten is actually the range that you are looking for. So you don't need to do any other thing. So this is how you write it. Or you can write it as negative infinity to 1 union 1 to what? Infinity. So this is your range. This is your what? Range. This is one common type of problem you would meet on that range. Another type is this. You have y equals square root of x plus 3. They say find the range of this function. Find the what? Range. Remember, range is your output. Now, I want to tell you that the lowest value you can put for x here, the lowest thing you can put for x here is what? Is minus 3. That's the lowest thing you can put for x here. So, and when you put x as minus 3, you have minus 3 plus 3, which is 0. So, it means that the lowest number you can get inside here that is possible is 0. Everything inside here, the lowest thing it can be is 0. Because you know that everything inside here should not be negative. It can be positive or at least 0. So if that is the case, if you put 0 inside here, what is square root of 0? Square root of 0 is 0. So it means your y is what? Numbers that are greater than or equal to what? 0. Did you get it? So your range y is numbers that are greater than or equal to what? 0. So that is your range. Y is greater than or equal to 0, or you can write it this way, from 0 to infinity. So this is your range. Another one, say you have y equals root x plus 3. If they give you something like, I hope you know these two are not the same. If they give you something like this, they say find the range. Please, what is the lowest value you can have inside a root? Always, the lowest value you can have inside a root is 0. So if you put 0, you have root 0 is 0. So it means that y is going to be root 0, which is 0 plus 3, which is what? 3. So it means in this case that your range is y greater than or equal to what? 3. Another way you can write it is to say from 3 to infinity. And I believe this is clear. I'm done with this. So please choose the next topic you want me to do. Write it quickly. Let us look at it.
Jesus.
Application of differentiation. I need more suggestions so that I will know. Who is saying trigonometry? Trigonometry is not in this course, please. Please, let us save time. Instead of doing differentiation is on my channel. I've already done it. So just go there and watch it. Choose a topic that I've not done, please. Some of you are just choosing very easy. Even this function we did is a very easy topic. You're just busy choosing easy topic. Continuity is a very easy topic. I was expecting to see application of differentiation or application of integration. Some of you are busy choosing something else. That is continuity. I think in continuity, I'll just use the example and summarize it. We'll just solve problem. That will be better since you don't have. See what I want to do. See what I want to do so that we can be fast. Now, since limit and continuity are easy topic, can we just solve problems under limit and continuity? Can we solve problem there? Then maybe for application of differentiation, I can now teach it. Do you understand? If you agree with what I've said, please say yes. Or if you have another suggestion, you drop it. Since limit and continuity are easy topics, can we just do it by solving problems there? Okay, thank you. Told you say solve like 3 questions. All right. So let's do that. So I'm still solving from that year 2024 question. It says determine the points of discontinuity of the function. Hey, Jesus. Please give me a few minutes to also renew this. Give me a few minutes. Every opposition of your A is the name. So I hope you can see me now. Sorry for the points of discontinuity in this board. So they said determine the that's the question. Okay, determine the points of discontinuity of the function 2x minus 5 divided by what? X squared minus 2x minus 15. I will be solving it. Determine the points. I mean the point of discontinuity of the function this, right? Yes. Let me see how the board looks. All right. Thank you. So, determine the points of discontinuity. Now, to find the point of discontinuity, a function is going to be discontinuous if the denominator is equal to 0. So, for you to find the point of discontinuity, you equate the denominator to 0. So, you say x squared minus 2x minus 15 equal to 0. That is the point of discontinuity when the denominator is 0. So, you can see that this is a quadratic equation. So, it means you need to solve this quadratic. So I'm going to do it x equal to 0. What am I going to do? I'm going to look for two numbers such that when I multiply them, it gives me minus 15. When I add them, it gives me minus 2. What are those two numbers? I multiply, it gives me 15. When I add, it gives me minus 2. 3 and 5. Yes, 3 times 5. So I have minus 5 and plus 3. So those are the two numbers. So I'm going to find the values of x here. So I'll say x minus 5 is 0, x is equal to 5, or x plus 3 is 0, x is equal to minus 3. So the points of discontinuity are 5 and minus 3, right? Yes. Let's see how their options are. The points of discontinuity are 5 and minus 3. So we'll have 5, comma, minus 3. These are the points of discontinuity. So this is what it is. So that is how it is in the option. Sorry. These are the points of discontinuity. So I hope it's clear. For you to get points of discontinuity, just equate your denominator to 0. Find the values of x. Those are your points of discontinuity. Alright? Now, just to help you summarize continuity, for those of you that were saying continuity, then I hope I can rub this. No, I believe I can rub this. So when you talk about continuity of a function, when you talk about continuity of a function, this is like the easiest topic you will learn in 103. A function is said to be continuous if the limit of that function, as x approaches some point a, if the limit of that function is equal to the function when evaluated at that point, then that function is said to be what? Continuous. If the limit of a function equal to the function itself when you evaluate it at the point, then it is said to be continuous. Assuming this was not revision, I would break this down in a way you would understand. But if I'm doing that, it's going to be unfruitful because we'll use the time for some other things to be explaining one thing. So this is very simple, but it's deep. It's very deep. Now, when you say the limit of a function is equal to this, first of all, you should ask yourself, what is the limit of a function? The limit of a function would exist because we have two-sided limits or one-sided limits. So if the limit of a function as x n approaches a point a from the positive side equal to the limit of the function as x approaches the point a from the negative side. If these two things are equal, that is to say right-handed limit and left-handed limit are equal, then the limit of a function exists. So you can say the limit of a function exists if the two-sided limits are equal. So that is it. So that is continuity. So if this is true, this is 1, and then 2, if f of a exists, then 3, and then limit of f of x as x approaches a is equal to f of a. Then these three conditions are what defines continuity. These three conditions. So why am I splitting it? Exam can split it like this for you. A function is continuous if the two sides of the limit are equal, if the function evaluated at the point a exists, if the limit of the function is equal to that function evaluated at that point. So if these three things are satisfied, then the function is said to be continuous. I'm going to use this to give you solve another problem under continuity before I do limits problem. Now see this question, which is common question in your CA. It's say see, they say determine the value of C that makes the given function continuous. So they gave you the function as this. They gave you this. So this is it. They said determine the value of C that makes this function to be continuous. Determine the value of C. So now when you have this kind of thing, they say determine the value of C or A or whatever they call it and make the function continuous. What you should just do is that if this function is continuous, it means that the limit from this side and the limit from this side must be equal. So all you just need to do is to equate these two sides and set x to be what? 2. Set x to be equal to 2 and find C. That is just all you're doing. So what I'm going to do, I'm going to say cx minus 2 equals ax squared plus 1. So wherever I see x, I'm going to put 2. So I'm going to have c into x, which is 2, minus 2, equals c into 2 squared plus 1. So 2 times c is 2c minus 2, equals, this is going to be 2 squared, which is 4, 4c plus 1. So what do I do here? I have minus 2 equals 4c. Now when this 2c crosses, it becomes minus 2c. Now what about this plus 1? When it comes here, it becomes minus 1. Abi? Yes. Minus 1 minus 2 is minus 3 equals 4c minus 2c is 2c. 2c. So if I divide both sides by 2, this would go, c becomes minus 3 over 2. So that is the answer. So this is like one of the kind of questions you meet under continuity. I hope this is clear to you. Yes. Can I move on? Now let's take a problem under limit. I believe I can rub this, right? Say move on if you are good. Say move on. 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 All right. Let's take this limit problem. So let's take questions under limit. And we know we are done with this part. So we have this still from 2024. So we have this find limit as x tends to 0 of sine 5x squared divided by 3x. So we want to solve this, and we still have some more limit problems to deal with. So let's solve this. So anytime you have limit as x tends to 0, one of the methods that should come to your mind is what you call L'Hopital's rule. L'Hopital's rule. We can solve this without L'Hopital, but I don't want to take you through that stress because this is exam. That is not even a stressful method, but let me just leave it. Let's learn L'Hopital. Anytime you have x tending to not just 0 anyway, any number, we can use L'Hopital's rule. So now first, when they say find the limit as x tends to 0, where do you apply L'Hopital's rule? Just to help you. You apply L'Hopital's rule for indeterminate limits. You apply L'Hopital's rule for indeterminate limits. Please, where do you apply L'Hopital's rule when you have indeterminate limits? Now, what do we mean by indeterminate? Whenever you evaluate your limit at the point you are given and you get an answer like 0 over 0, this is what? Indeterminate. This is what? Indeterminate. Once you evaluate and you find that your answer is 0 over 0, you have to apply L'Hopital's rule. You evaluate and you get infinity over infinity, you also apply L'Hopital's rule. If you get infinity times 0, you also apply what? L'Hopital's rule. So you have so many, but these are the common. In fact, this is the major one you'll be meeting in your exam. So let's check. Wherever you see x, what are we going to put? we're going to put 0. Now, some students usually make mistake. If you get, let's say 0 over any number, let's say 0 over a number 10. This is not indeterminate. 0 over a number is 0. If you have a number, let's say 10 over 0, this is also not indeterminate. This is what? Infinity. Then you have these two cases. You don't apply L'Hopital's rule. You don't apply. This is only where you apply L'Hopital's rule. 0 over 0 or this or this. But for 0 over a number, you don't apply L'Hopital's rule. 0 over any number is 0. Any number over 0 is infinity. So for these two, you don't apply L'Hopital's rule. So don't mix it, please. And let's check. I'm going to replace x with 0. So I'll have sine 5 into 0 squared divided by 3 into 0. So let's see. 0 squared is 0. 0 times 5 is 0. What is sine 0? Sine 0 is 0. Divided by 3 times 0 is 0. So can you see that we are getting 0 over 0, which is indeterminate. So it means that we need to apply L'Hopital's rule. So what does L'Hopital rule say? L'Hopital rule says differentiate the numerator, differentiate the denominator, test the limit again. L'Hopital's rule says what? Differentiate the numerator, differentiate the denominator, test the limit again. When you test the limit again, and it still gives you 0 over 0, what do you do again? You apply L'Hopital's rule again, which says differentiate the numerator, differentiate the denominator, and test the limit again. You keep doing that, all right? That's L'Hopital's rule. So can we do it now? Yes. So what am I going to do? I'm going to differentiate the numerator, and I want to believe you understand differentiation already. So if I want to differentiate the numerator, let me do the numerator, which is sine 5x squared. So if I want to differentiate something like this, I will start from the inner function. Start from where? The inner function. Please, what is my inner function in this case? It is 5x squared. So the concept says differentiate the inner function, differentiate the outer function, write back the inner function. That is the idea. So let's do it. If you differentiate 5x squared, what do you have? You have 10x. If you differentiate sine, what do you have? Cos. Then you write back what? 5x squared. That's the concept. Is that clear to you? Yes. Now that is for the numerator. Let us do the denominator. My denominator is 3x. If I differentiate 3x, please, what do I have? I have what? 3. So I'm going to write it the way it should be now. So it means my new function is going to be 10x cos 5x squared all over the denominator, which is 3. So what I'm going to do now is that whenever I see x, I am going to replace it with what? 0. I don't even need a soothsayer to tell me that this whole thing will be 0. Let's check. Whenever I see x, I'll put 0. So I have 10 times 0, which is 0. 0 times everything up is 0. 0 over 3 is what? 0. So it means that the limit of this function is 0. Please, if it is clear, say yes. Next question. If it is clear, say next question, please. So, is it clear? Is it clear? Any question? Next. All right. Thank you. So let's solve this. And you have limits, evaluate limit as x tends to 0 of sine cube into 2x divided by x cubed. So evaluate this. Can you attempt it? 30 seconds. Any answer? Zero. Answer is 1. All right, let me solve. All right. So let's solve. And after this, I don't know, maybe I should still give you one more. Okay, we still have some areas of limits, but those areas are simple. The main area of limit is L'Hopital's rule, but I'll give you those areas. So you have limit as x tends to 0. So what you need to do is wherever you see x, put 0. I'm sure you know it will be 0 over 0 if you do it. So don't waste your time in exam. Whenever you're seeing sign, you should know that the numerator will be 0. Whenever you're seeing only x at the denominator, or even x attached to a number, you should know it's going to be 0. So it means you can apply L'Hopital's rule. L'Hopital's rule means you're going to differentiate your numerator, differentiate your denominator. But if you want to differentiate, it might be long. It might be long. I'm going to use another rule, and maybe I'll still use L'Hopital if you want it. So, okay, let's start with L'Hopital, since that is what you are used to. So, L'Hopital says you differentiate your numerator. Abi, this is what you have. I hope you know that this thing can still be written as sine 2x raised to power 3. You know these two things are the same, right? Yes. And because they are the same and I want to differentiate this, I'm going to start. This is going to be a bit long. I'm going to start with my inner function. If I differentiate, let me write it, I believe you know. If I differentiate my inner function, which is sine 2x, to differentiate sine 2x, I'm going to differentiate 2x first. I'll have 2. If I differentiate sine, I'll have cos. I'll write 2x. So to differentiate this whole thing, you're supposed to even know it against differentiation. To differentiate this whole thing simply means differentiate your inner function, which is this. I've done this inner function, it gave me this. Differentiate your outer. Your outer means multiply by the power times this power 3 into, you write back sine 2x raised to power 2. You subtract 1 from that power. So this is what you have when you differentiate. 3 times 2 is 6 cos 2x into sine 2x raised to power 2. So that is our numerator. What about, my God, this thing will take us time. Let's not use L'Hopital's rule because of this power, which is 3, means you apply L'Hopital's rule 3 times. So let's not use it. Let's use this other method, please, for the sake of your exam. The other method says, see what I'm going to do? I know that sine cube 2x is same thing as sine 2x raised to power 3 all over x cubed, right? Yes. Now, this thing can be written as sine 2x all over x all to power 3. I hope you know it's the same thing. Yes. Now, see the concept. Let me clean this because I'm not going to use the L'Hopital's rule. It's too long. See the concept I want you to know. You need to note at any time you have limit as x tends to 0 of sine of theta over theta. What do we mean? When this angle and this angle, once they are the same and your limit is tending to 0 and these two things are the same, then the answer is 1. So what is the idea? We want to do the same thing. This is 2x. We want here to also be 2x so that the two angles will be the same. So if that is the case, for me to make here 2x mathematically correct, I'm going to just say sine 2x divided by 2x. For this thing to be correct, I have to put 2 here. So that when this 2 cancels this 2, I'll come back to this thing, right? So all raised to power what? 3. Now, you already know that when you have sine of 2x over 2x, the limit of sine of 2x over 2x is 1. The limit of sine of 2x over 2x is what? 1. So you now have 1 times 2 is what? 2. 2 raised to power 3 is what? 8. So it means that the limit of this is equal to 8. If you got it, let me see. Seems like nobody got it. If you understand what I did, please say yes. If you understand it, say yeah. Nobody is saying yes yet. So nobody understands it. Nobody? Should I give another example like this? Should I give another example like this? So, you're not telling me what you want me to do? Okay, you say you forgot to raise to power 3. I'm praying that you will not see it, Noah. Oh, so I think I should move on. All right. So I think I'm done explaining limits under L'Hopital's rule. So the other kind of limit you need is limit at infinity. Limit at infinity. That's the other kind of limit you need. Say you have 3x squared minus 4x plus 1 divided by 2x squared plus 5x plus 7. So limit at infinity. So the concept behind limit at infinity, let me give you two. I believe you know this already. So you have limit as x tends to infinity of, let's say, x raised to power 3 minus 4x divided by x fx raised to power 2 plus 7x plus 1. Lesson number 3, you have limit as x tends to infinity of 7 7x to power 4 plus 5 divided by 2x squared plus 3. Now, I'm going to just go straight to the short way, which some of you know. Anytime you have limits tending to infinity, you can have 3 possibilities. The first possibility is when the highest powers of x at the numerator and denominator are the same. What's the highest power of x at the numerator? It is 2. What's the highest power of x at the denominator? It is 2. So once the highest power of x at the numerator and denominator are the same, then your limit is the ratio of their coefficients. So this limit is going to be, what's the coefficient of this? It is 3. What's the coefficient of this? It is what? 2. So your limit is the ratio of their coefficient, which is 3 over 2. Because their powers, highest powers are equal. Is that clear? Yes. Now the next type you would have is when the power at the numerator is greater than the power at the denominator. The power here is 3, the power here is 2. So when the power at the numerator is greater, your answer would always be infinity. The last type you have is when the power at the numerator, okay, I wanted to give 5 like this. So the last type is when the power at the numerator is less than the power at the denominator. This is 4, this is 5. Once this one is smaller than this, your answer would always be 0. So I hope it is clear. If it is clear, say move on. I'm done with limits. These are the necessary things in limits. So if it's clear, I want to do application of differentiation. So if it's clear, say move on to that. If it's clear, say move on to that. Say move on. Okay. So let's do application of differentiation. Please, you are still here and you've not hit the like button, please do so. You're yet to subscribe, do so. Please, I want you to share this video. I'm going to give you 1 minute. I'm going to pause now, right? Yes, I want to pause. I want you to share it. This part I want to do is very important part. I might just do this part and application of integration and stop so that you can rest. Or I'll just solve problem and just stop. So please, share this video, please. Share the video. If you have shared it, hit the comment, say done. Please, I want you to do this now. Share it. Tell them to join this live. If you have done it, please say done, please. Let's know those that have done this. I need you to share it, please. So that I have energy to move on. No, I say done. Okay, no, I say done. God's will done. Thank you. Tochi done. John Martin done. Thank you. Please help me share it and come back so that we can move on. All right. If you have done it, please say done so that more people will know about this. All right. Thank you. Done. Thank you. Now, don't forget that we have a WhatsApp group, Prime Concepts Learning Hub, that every one of you need to join. Why you need to join this is against our next classes, even second semester. You need to be on that group, and I'll need every one of you to share the link of that group. I'll soon lock that group and begin to work with just those on the group. So share it and invite more people. Now let's move on. Under application of differentiation, there are a couple of things we are going to look at. We're going to consider a couple of things. So one of the things we are going to look at is the first application we are going to consider is tangent and normal. Please, like I said, I have on this channel a video of differentiation. I've done everything on differentiation. Some of you know about it. Some of you don't like to watch videos that are already uploaded. That is the best way we can save time now. Just when we finish, go back, watch the video on differentiation. It will help you. I have a video on introduction to integration. Look at it, it will help you because we won't have time to do all those things in this video again. All right, so let's look at tangent and normal. So now, what is a tangent? A tangent is a line that touches a curve at one point. So if I have something like this and I have, say this is a curve, if I pick a point and draw something like this line I have drawn is a tangent. This line is a what? Tangent. If I draw another line like this, notice that this line is perpendicular to this. So this one I have drawn is what? Normal. So a normal is a line that is perpendicular to a tangent. Normal is a line perpendicular to what? Tangent. Are you following me? Now, you should know that since this is your normal, this is your tangent, both of them are perpendicular. One of the things I want you to know is that if two lines are perpendicular, if two lines are perpendicular, comma, then m1, m2 is equal to minus 1. So if two lines are perpendicular, the product of their slope is going to be what? Minus 1. So it means that if m1 is the slope of the tangent and m2 is the slope of the normal, then m1 times m2 is going to be what? Minus 1. This is a very important point for you to note, that the product of the slope of tangent and the slope of normal is going to be minus 1. Let me give you an example. E.g., if m1 for a tangent line is 5, find the slope of normal. What is it going to be? They gave you the slope tangent to 5. They say find the slope of the normal. What will the slope of the normal be? The slope of the normal, I'm going to use this formula, right? I know that m1 is the slope of tangent, which is 5. So I'm going to say 5 times m2 equals minus 1. Then m 1 over 5. So it means that the slope of my normal is minus 1 over what? 5. Are you following me? Yes. So that's one of the things you should know. Second point I want you to know, number 2, is that if two lines are parallel, their slopes are what? Equal. If two lines are parallel, their slopes are equal. Did you get it? Yes. Now, let us move further. Number 3 points I want you to note is that the slope of a tangent is obtained by differentiating the curve. The slope of a tangent is what? Obtained by differentiating the what? Curve. The slope of the tangent is obtained by differentiating the curve. I'll give you an example so you understand. Hey, what is happening? What is happening? You all is just extremely weak. All right. I've almost pierced every part of my work. I'm beating nails. Now let's take an example. Say you have y equals 2x squared minus 4x is the equation of a curve. Now find the slope of the tangent. Find the slope of the what? Tangent. So they say y equals this is the equation of a curve. Find the slope of the tangent. I told you that the slope of a tangent can be obtained by differentiating the what? Curve. So it means that the slope of the tangent, which is m1, is equal to dy dx, differentiating the curve. So if you differentiate this, what would this give you? 2 times 2 is 4. So this is going to give you 4x. If you differentiate this, it will give you minus 4, right? Yeah, so it means that the slope is equal to 4x minus 4. And if they say find the slope of the tangent at x equals 1, so let's use that. They say find the slope of the tangent at x equals 1. So it means m1 is going to be, wherever I see x, I'm going to put 1. It's going to be 4 into 1 minus 4. So 4 times 1 is 4. 4 minus 4 is what? 0. So it means that the slope is equal to what? 0. Do you understand? Yes. Let me give you one to do. So say you have y equals 3x cubed minus 5. Say you have this, find the slope of tangent at x equals 1. So do it and tell me your answer. 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 All right. So thank you. I'm seeing. So the slope m1 is going to be the y, the x. So differentiating this 3 times 3 is going to give me 9x squared, right? Then this is going to be what? 0. So it means wherever we see x, please, can we put 1? Yes, we have 9 into 1 squared, so which is equal to 9. Right? So you can see how simple it is to get slope of a tangent. Very easy. Just differentiate the function. And what if they now want you to find the slope of the normal? For you to find the slope of the normal m2, you just know it is minus 1 over m1. Abi, if you're assuming they wanted you to find the slope of normal, so you just say m2 is minus 1 over this, which is this. So this becomes the slope of your normal. So if at this point it is clear, say please, it is clear. If it is clear at this point, say it is clear. Let me now move to the next part, and then I'll be done with tangent and normal. If it is clear, tell me it's clear. It's clear, right? Yes, thank you. Now, the next thing, one of the things they would always require you to get, remember we're looking at application of differentiation to finding equation of tangent and normal. So anytime what we are trying to find is equation of tangent line and equation of normal line. These are actually straight lines. Now, if you want to find equation of a line, two things you need to be able to find. One is slope. Let me write it. To find equation of a line, you need number one, slope. Number one thing you need to find is slope. Have I taught you how to find slope? Yes. You need to be able to find slope, and I have taught you how to find slope. Number two thing you need to be able to find is intercept. Is what? Intercept. Intercept is denoted by C. Intercept is denoted by what? C. How do you find intercept? Intercept is C, which is equal to y1 minus mx1. You have found your intercept. Once you find slope, you find intercept, you can get equation of any line. And the equation of any line is given as what? Y equals mx plus c. This is your equation. Please, before you can find equation, what are the two things you need? You need slope. I've taught you that you can get slope by differentiation. Second thing you need is what? Intercept. You can get formula. Once you get intercept, you substitute m, which is slope, substitute c, which is intercept, and you are done. Can I take one problem? Yes. So write this. So see this. Let's say example y equals, see, find the equation of the line tangent to the curve y equals 3x squared plus 1 at what? 1 comma 4. I'm going to use this as our first example. I'm just going to solve 2 questions here and I'm done with this topic. I'll go to the next part of application of differentiation. So follow me, just stop and follow me. Now they said find the equation of the line tangent. We are looking for equation of tangent to the curve this. In order for us to find equation of tangent, what are the 2 things we need? We need slope, we need intercept. Let's start with slope. Slope means we need to differentiate the y, the x. So if I differentiate this, I have 2 times 3, which is what? 6x. If I differentiate 1 is 0. Now, I'm going to, wherever I see x, what am I going to put? 1. Remember the first part here is 1, the second part is, the first part here is x, the other part is y. So, but what I have here is x. So wherever I see x, please, what will I put? I'll put 1. So I have 6 into 1. And what is my slope of tangent? It is 6. I've gotten slope. What's the next thing I need to find? Intercept. To find my intercept, I'm simply going to say C equals y1 minus m1 x1, right? Yes, please, what is my y? My y is 4. So I'm going to say 4 minus slope, which is C, into x. My x is 1. I'll put this. So I have 4 minus 6. What is my answer? Minus 2. So how do I get the equation of the tangent? I'm going to use this formula. So now, when you're using this formula, the only thing you are substituting is m and c. You're not substituting y and x. You leave it like that. So the equation is just going to be what? Y equals m. What is m? 6. 6x, then plus c. What is your intercept? Your intercept is minus 2. So if I write it, I'll have minus 2. So this is the equation of the line. If I like, I can write this like this. Y minus 6x plus 2 equals 0. Any one can be found. Please, if this thing is clear, say it is clear. If it is clear, please say it is clear. Let me know. If it is clear, please tell me that it is clear. So it's clear. Noah say clear. Joshua say clear. Now, if it is clear, I want to add to this question. And what am I adding? Find the equation of tangent and find the equation of normal. Find the equation of what? Normal. Find it and give me the equation of normal quickly. Then I'll give one more question. I'm done. Find the equation of normal. Find the equation of normal. This one is small. Not that you are rushing me, we can stay. I'm not seeing any answer yet. Okay. Thank you, God's will. Thank you. So for you to do that now, for you to get the equation of normal, first you need to find, I want to rub here. First, you need to find the slope of normal. The slope of normal, m2, is going to be minus 1 over m1, which is minus 1 over 6. We've gotten this. The next thing you need to get is the intercept of normal, which is c equals y1 minus m2 x1. Abi? So c is equal to y1, which is still 4, minus m2. Now m2 is minus 1 over 6. Then x1 is still 1, right? So then c is going to be 4 minus 1 over 6. If you do this, you're going to have 6 times 4 is 24. 24 minus 1 is 23 over 6. So the intercept is 23 over 6. So for me to get my equation of normal, I'm going to use this formula, which is y equals slope, which is minus 1 over 6x. My intercept is plus 23 over 6. So this is what I have. If I don't like this 6 that is under, I'm going to multiply everything by 6. If I multiply everything by 6, this becomes 6y equals minus x plus 23. Because I've multiplied everything by 6. This 6 will go, this will go. Only this one will carry 6. So this is written as 6y plus x minus 23 equals 0. So that is the equation. Either this or this is correct. You see in your option. All right. I believe it's clear, Seth. Is there need for any example again? I don't think so. So can I go to the next application? If you want me to go to the next application, say go to the next. If you want another example, yes, say example. Let's know what you want to do. If you want me to go to the next, please say go to the next application. Or another example, let me know which one to do. If you want next example or next application, talk to me, talk to me. I'm not getting you. Another example, only one person. Let me give one more example. I think we need to tidy up. This video is already after 3 hours. We might likely end with application of differentiation so that everyone would rest. And maybe, just maybe, see what to do again tomorrow. We have time. Okay. I wish I have your CA here. I don't have your CA. That's the only challenge I have. So find equation of tangent to the curve y equals, let's say, 5x cubed minus 2x at 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 0, comma 1 at this point. So can you solve this fast? Or I think I should solve it because of time. Let me solve it so we save time. Now they say find the equation of tangent to the curve this. So first you need to find the equation of tangent, you need to find your slope. So our slope m1 is going to be the y dx. So if I differentiate this is 3 times 5, which is 15x squared minus 2. That's what you have. So now I'm going to put x as 0 to find my slope. So I have m1 equals 15 into 0 square minus 2, and my answer is minus 2. So it means my slope of tangent is minus 2. What about my intercept? My intercept is c equals y1 minus m1 x1. So c becomes y1, which is 1, minus my slope, which is minus 2, and x1, which is what? 0. So it means my c, watch, 0 times minus 2 is 0. So my c is just going to be 1. So if I use this formula to write my slope, my equation is going to be y equals m, which is minus 2x, then plus c, which is 1. So this is the equation of my tangent. Or I can say y plus 2x minus 1 equals what? 0. Is that clear now? Yes. So I think I can move to the next application. The next application is what we call optimization, and I'll do it step by step. So first thing I want you to learn is stationary slash turning point. Stationary point or turning point. A stationary point or turning point, stationary point and turning point are the same thing. A stationary point or turning point is the point where the first derivative is equal to 0. The point where the first derivative is equal to 0. So it means for you to get stationary point, you do the y, the x equal to what? 0. That is your stationary point. For example, equals 2x squared minus 4. Right? Yes. 2x squared minus 4. They find stationary point. So to find stationary point, you find the y, the x, equate it to 0. So let's do that. The y, the x, if you differentiate this, 2 times 2 is 4x. Then, okay, let me make this like this. That is 2x squared minus 4x. Find the stationary point. So you have this times this is 4x minus 4 when you differentiate. So to get the stationary point, you equate to 0. So you would say 4x minus 4 equals 0. 4x equals 4. Then x becomes 4 over 4, which is 1. So it means that your stationary point is x equals 1. Stationary point is x equals what? 1. Is that clear? Yes. So the next thing is what you call critical point. Critical point is very similar to stationary point, but it is not exactly the same. So let me just let you know so I don't drag your time. I need to let you know that all stationary points are critical points. All stationary points are critical points. Critical point has 3 definitions. So a critical point is 1, a stationary point. So it means if they say find critical point, one of the things you're going to do is to still differentiate and equate it to 0. So critical points are stationary points. Number 2, critical points are end points. You're going to learn what end point is when we move further, but just know that critical points are what? End points. Critical points number 3 are points where the where a function, a point where a function is discontinuous. Critical points are points of discontinuity. So what are the 3 definitions of critical points? A critical point is a stationary point. A critical point is an end point. A critical point is a point where the function is discontinuous. I will explain these 3 things for you. So if you have something like this, let's say y equals, let's say 3x squared minus 4x. Y is equal to this. In the interval, you'll be seeing this in the interval, s is 0 less than or equal to x less than or equal to 1. So y equals this in the interval, this, right? Yes, they say find the critical points. So for you to find the critical points, you need to differentiate this and equate to 0. So you differentiate. So the y, the x. So if you differentiate this, 2 times 3 is 6x minus 4. So you're going to say 6x minus 4 is 0. 6x is equal to 4. X is equal to 4 over 6, which is 1 over 3. So what you have just gotten is a stationary point. Now notice they gave you a boundary. They say x is from 0 to 1. This boundary, this is known as end points. Anytime they give you boundaries like this, you call them end points. They are points that bounds a function, right? So they are known as end points. So if they ask you what are your critical points, your critical points are going to be 0, 1 over 3, and what? 1. So these are your critical points, everything. So an end point, that is what we mean. Remember, x equals 1 over 3 is actually a stationary point. So that's why I would say critical point is a stationary point, is an end point, and it is a point of discontinuity. And what do we mean when you say a point of discontinuity? It means that whenever you differentiate a function and that function has a denominator, you equate the denominator to 0 to get the critical points. So I didn't ask you. I believe this is clear. Let me refill my marker 1 second. Okay, 2. Okay, thank you. It's 2 over 3. Thank you. It's an oversight. It's 2 over 3. Okay, thank you. It's 2 over 3. I've seen it. Let me refill my marker. Don't you see you has called me? All right. So that is critical points. Let me give you one more question on that critical points. Say you have this. I don't want to give don't sound too long. Say f of x equals x plus 1 over x. Find the critical point. I'm going to solve this. So they say we should find the critical points here. So what I'm going to do, I'm going to differentiate this, right? Yes. So this is a rational function. So we need to apply quotient rule. So the y, the x, in this case, this is rational function. So according to quotient rule, I told you, differentiate, it is going to be bottom diff top. Watch my video on that differentiation, please. Bottom diff top minus top diff bottom over bottom square. So bottom is x, differentiate top. If you differentiate the top, you have just 1. Bottom is top minus top, you write the top x plus 1 minus top diff bottom. If you differentiate bottom, you have 1 over bottom square. If you get this, you have x squared, right? So this is going to give us x times 1 is x. This times this is minus x. This times this is minus 1. So what do I have over x squared? What do I have? This can go, and I'm left with minus 1 over x squared. So this is what I have as the y dx. So if you want to find the critical point, what are you going to do? You're going to equate the denominator to 0. Remember, I told you whenever your denominator is equal to 0, that is known as a point of discontinuity. That is what I have said. So it means a point of discontinuity is also a critical point. So to get the critical point here, equate this denominator to 0. And what is the denominator there? X squared is equal to 0. So x is equal to 0. So it means that the critical point of this is just x equal to what? 0. I believe it is clear. Let's look at the last part of this. So say move on if it is clear. Let's look at the last part of that application now, which is maximum and minimum. If it is clear, please say on. We say an application or integration. Some of you, you will choose one. When we are doing it, before we even finish, you're already talking of another one, as if that one is no longer important. So, all right. I think what I should do at this point is to solve question, maybe 4 questions now, because I want to end this video. We have stayed, and I believe some of you are tired actually. So I'm going to solve, rather than taking more time, I'm going to solve 4 questions, 2 under application for maximum and minimum points, 2 under application of integration. Then we'll call it a day, right? Yes. I believe it's okay that way. Do you agree with me? Before some persons will faint, the persons that are with me will faint. So we need to. So now let's look at this problem. So see this. Find the critical. Sorry, I'm not talking about critical again. Find the maximum and minimum points of f of x equals 18x to the power 4 minus 2x cubed it's not going this far. It's not good that far. f of x equals 4x cubed plus 9x squared minus 12x plus 13 minus 3 less than or equal to x less than or equal to 2. So they say find the maximum and minimum points of the function this, right? Now one of the things I want you to know is that, please follow me. Once I solve this, the concept will be clear to you. So what I want you to know is that you have 2 types of maximum. There are 2 types of maximum points you can have. So number 1 is what you call relative maximum. Number 2 is what you call absolute or global maximum. So these are the 2 types of maximum. Please, what is absolute maximum. Absolute maximum is the highest of all the high points. Absolute maximum is the what? Of all the high points. If, for example, you say x equals to 3 and 5 gives you corresponding values of y to be 7 minus 2 and 1. If you say this gives you these corresponding values, so which of these have the highest values? Which of this is the highest? The highest value here is 7. So it would mean that your maximum point, your absolute maximum is going to be what? 2. That is the point. While your absolute maximum value is going to be what? 7. Your absolute maximum point is going to be what? 2. Your absolute maximum value is going to be what? 7. That is the highest of all the high points. Are you getting me? Yes. So then, if for example, all these things are maximum points, and this one is the absolute, it means that these other two are going to be relative maximum. Absolute is only one. The remaining ones, you now call them relative or local maximum. Are you getting me? We're going to use this example to explain. Then, for minimum points, same way, we have two types of minimum points. We have what? Relative minimum, and we also have what? Absolute. Absolute or global minimum. Are you getting me? So what is absolute minimum? The lowest of all the low points. The lowest of all the low points. What is relative minimum? The remaining of those low points are now the relative. Is that clear? Yes. Now, for you to get this, so let us solve. See the steps you're going to follow. First step is find your critical point, or what you say your stationary. So I'm going to differentiate this. So I have the y, the x. If I differentiate this, I have 3 times 4, which is 12x squared, plus this times this, which is 18x, and this is what? Minus 12. So this is what I have when I differentiate. So what am I going to do? I'm going to equate it to 0 to get my critical or stationary point. So I'm going to have 12x plus 18x minus 12. I'm going to equate this to 0, right? Sorry, 12x squared, this is a quadratic. So I'm going to equate this to 0. So now you notice that I can reduce this, is a quadratic. I'm going to solve, but I can reduce this by dividing all through by 6. If you divide 12 by 6, you have 2x. By 6, you have 3x minus, if you divide this 12 by 6, you have what? 2 equal to 0. So we can solve this by quadratic. Look for two numbers that when you multiply those two numbers, it gives you minus 2. Minus 4 rather, because this times this is minus 4. When you add those two numbers, it will give you plus 3. What are those two numbers? 4 times 1 is smart. So we're going to do plus 4 minus 1. So you have 2x squared plus 4x minus 1x minus 2 equals 0. So you factorize this by grouping. So what are you going to have? What is common here? This part is normal factorization. So what is common there? So what is common there? I have 2x. I bring it out. I'm left with x plus 2. Here must be x plus 2. What should I place here? I'm going to place minus 1 here. So I have 2x minus 1. Then I have x plus 2 equals 0. So what do I have? 2x minus 1 equals 0. X becomes 1 over 2. Or x plus 2 equals 0. X becomes minus 2. So what it means is that my critical points are, remember your critical point includes your end point. Can you see that we have an end point here? So my critical point is going to be, my critical point will be minus 3, which is this, then followed by minus 2, followed by what? 1 over 2, followed by what? So these are my critical points. But that is not what we're looking for. So, but I've gotten my critical point. The question says find the maximum and minimum points of this. Right? Yes. I am finding it difficult because of space. So if you've copied here, I want to rub this part. I want to rub this part so that I can proceed. Say move on. I want to rub this part or even this part since I found my critical points. So can I rub now? Yes, I believe so. So see the idea now. The idea is we're going to use all of these values and evaluate this function and get our answers. So that's what we're going to do. So I have f of, I'm starting with this f of minus 3, which is equal to 4 into minus 3 raised to power 3 plus 9 into minus 3 squared minus 12 into minus 3 plus 13. I'm going to evaluate this. I'm going to do the same using minus 2. So I have 4 into minus 2 cubed plus 9 into minus 2 squared minus 12 into minus 2 plus 13. I'm going to do the again. So f of 1 over 2, this is going to be 4 into 1 over 2 cubed plus 9 into 1 over 2 squared minus 12 into 1 over 2 plus 13. I'm going to do again for the last part, f of 2. 4 into 2 cubed plus 9 into 2 squared minus 12 into 2 plus 13. So I want you to give me the answer to each of these parts. I don't have calculator, so help me punch the answer to the first one, second, third, and fourth. Please tell me so that we can draw the answer there. Tell me. Help me punch them. Tell me. So, okay. To say, I don't understand your answer. I want you to give me the answers in a way. Use calculator and punch this now so we don't waste time. Wow. My God. Nobody's giving me answer. You're taking time. 2 except for 1 over 2. I don't understand your answer format. F of minus 2 is 41. That is what I want to hear. So somebody said f of minus 2 is 41. Thank you. I want to get other answers. Thank you, Chineche. Who else? No, I say we are tired. Thank you. Me, I'm also tired. So I think after this question, I will stop. So every one of us will rest. But if you have any question, I will allow you drop it on the WhatsApp group and I'll be responding to it. So I think that's what we're going to do. Nobody is dropping answer for us. Do so that we can call it a day from this and everybody will rest. So nobody is dropping answer. Let me calculate. For f of minus 3 is 22, thank you. F of 2, 57. F of minus 3 is 20. Is it 22 you said now? 22, 22, thank you. 22. And this one says 57, thank you. Then it's remaining for this one. Most of you are running from decimal parts. So let me try to do it. 0.5 times 0.5 times 0.5 times 4. That's 0.5. 2.75. 2.75 minus 6 plus 13. So this one is 9.75. This one is 9.75. So let's draw the conclusion for our answer. And I believe that is what they got, Abby. Okay. 39/4, which I think is 9.75. Right? Thank you. So see what we're going to do now. Remember, we're trying to get maximum. Now, if you look at this, among 22, 41, 9.75, and 57, which is the highest value? The highest value is what? 57. So it means that the maximum value is 57. And what point gave us 57? The point that gave us 57 is 2. So our maximum point, which is actually our absolute maximum point is 2. While the value is what? 57. So this is how you see it in exam. You see it as 2, 57. Where the first one is the maximum point, while the second one is the maximum value. What about the minimum? The minimum is the lowest of all of them. So among all these three, which one is the lowest? 9.75. So your minimum value is 9.75, and minimum point is 1/2. Your minimum point is what? 1/2. Is that clear? Yes. Your minimum point is 1/2. I hope this is clear. It means the remaining ones, which is -3 and -2, these ones are local minimum and maximum. They are local. So that's how you get absolute maximum. Once you do your evaluate, the highest of all of them is your absolute maximum. The lowest of all of them is your absolute minimum. I think I'm going to stop here. We have tried. I know you are tired, so I don't keep pouring water on a basket. So I would need to stop here. But remember, we have our WhatsApp group. Just after this live session, I'm going to post the WhatsApp group link on the comment of this video, and you click it so that it will bring you to the WhatsApp group. If you have any question, drop it. I'll be solving it and be snapping it. I'll solve, snap, and send to the WhatsApp group. I'll be explaining for those that have any question between now and tomorrow. So I really appreciate everyone that participated in this live session. I appreciate everyone that shared this. I appreciate those that have been dropping their likes and comments. I appreciate you. Remember, this is not the end. We still have a lot to go with in second semester. We have practical physics, we have practical chemistry, we have physics 102, chem 102, maths 102, and so many other things we have in our second semester. So do well to stick in this channel. You are yet to subscribe, hit the subscribe button. We'll meet again in our next class. Until then, I remain Prime Concept. Thank you. Thank you, thank you, thank you, thank you, thank you.